and tell them. It's a bigger process, so we need to engage with the departments and align everything. So if you are being picked up by your parents, still you have to fill the form so that we know when is your checkout date, and all the options are available in the form. And make sure that whatever goodbyes you have to do tomorrow and day after, you have to do it very quickly, because last time there are students who missed the flight because of the goodbye. Okay, so we will not give you another flight. You will be sitting in Sonipat, which you do not want to. Okay, because there's no Lodha Genius program happening. So please make sure that you get ready on time, take shower on time if you're taking shower, and then get on to the shuttle which is assigned to you, because this is very important. Please do not put us in stress or trouble. We have enough of that, and we just make sure that you are doing your bit. Then everything will be as smooth as possible. So please make sure that you do all that and come in advance to your shuttle or your cab, whichever is assigned to you. And regarding the cab and the shuttle, we will see if it is a cab or a shuttle, depending on how many people are going to the airport, to their destination, or the railway station or bus station during that time. So do not worry whether it will be a cab or a shuttle. So it is completely a logistic thing, and leave that to us. And there are some important forms, again, that you will get. So Manvendra, can you explain about the form, what they have to, what you will be sent to you and all that? I mean, sent to them.
Yeah. Hi, good morning. So we are also you have a question? What is your question?
Is it possible to go in the shuttle with your friends? Which friends? Huh? No, just enter your details. You'll have to go in the shuttle, which is, because again, we have 195 students to handle, okay? So we cannot give you your preferences. Your aim for tomorrow and day after is that you reach home safely, okay? So then we can hang out with friends later. But then you have to follow whatever we are asking you to do in terms of your transportation, whether it's cab or shuttle. Yes, question there. So the shuttles are provided depending on your destination time there. Are you asking when do you want to check out? So if you check out in the morning tomorrow, you will not get your certificates. So, yeah, so after 5:30 p.m. Yeah.
Hi. So as you know, we are growing each year. We want more people to connect with us, and precisely for that, we wanted you guys to sort of, reach out to people around you, schools around you, to connect with them so that they also know about this program, because many people still don't know about the Lodha Genius program. So for the same purpose, we'll be sending out a form to you today, where you'll be asked to nominate 5 schools around your neighborhood. It could be your friends' schools, relatives' schools, or anything at all. So you need to nominate 5 schools, and we'll tell you what you will have to do with that information later on. But for now, your only task becomes that any familiar school in your neighborhood, your locality, your friends' schools, etc., anything at all, just nominate 5 schools, and from there we'll let you know what to do about that. But that's your task for now. So thank you so much.
Your presentations, please stick to the time, okay? So it's 10 minutes per presentation, and then you have 5 minutes Q&A, and I guess there will be many Q&A, but then that's why if you need more questions, time for questions and interactions, you have to stick to your 10 minutes, otherwise it won't be as exciting as it should be. So we are going to start now exactly in 2 minutes. Vijay is almost here, so he'll address you, and then we can start with your presentations. All right, I think it's time. So, I think we've had a long journey in this 1 month, and Vijay was there in the beginning and has been engaging with you in some way or the other. But I think it's really nice to have him here at the closure and to say a few words to you before you all start the presentations and also end this program. But it's actually ending only the summer. The program doesn't end here, okay? So the program is till you get your first job. That's as Lodha says. So over to you, Vijay.
Thank you very much, Ambika, and good morning, everybody. I was, as Ambika said, here at the start, but I had to run off to deal with some crisis, and unfortunately, I couldn't be with you the rest of your course over here in the summer. But I've been in touch regularly with Ambika and her team, and it's just pretty amazing to see how this year has gone compared to the previous year, which was terrific. So it's standing on the shoulders of all what was happened last year that this year has come. So I really, I'm full of admiration for all of you and your enthusiasm and drive to be here for this period. And how many of you were here last year also? Good. And I'm sure that those who were here last year were good mentors and support systems for those who are here this year. And how many of you are TAs over here? No TAs here? None. Yeah, okay, a few here. Good. So there are lots of them, right? About how many TAs are there in all? About 80? 50 to 20? 86. So they are an extraordinary support team. Many of them, a lot of them are from students from here, so they would help you in your transition. So let me just tell you very briefly what I think the impact of this program can be on your lives. There are no shortage of pulls and pressures on all of you to do this or do that or become this or become that. But life is also largely about exploring what you want. And the trouble with that way of looking at things is that we don't know what we want. So if you are subject to various pulls and pushes, you end up deciding something without knowing what you want. Or if you decide not to be pushed, you take up something, again, without knowing what you want. Here is an opportunity where you meet literally over 100, 200 people who are like you, your TAs who have been like you only a short while ago, the best teachers from all over the world who work with you very intensely in every subject, in every kind of area, and then you can decide what you want to do. But what you will also learn from this, apart from specifically in the courses, is meet people who are from a variety of different contexts, regions, backgrounds. And that is the most important thing in our lives. The friends we make in this 1 month will be your friends for life. And as you go ahead in life, what you do, they will be there to help you, give you a hand, and you will be there to help them. And that's what makes the world an interesting place, and that's what people like you can change the world. So all the best to you, and great strength. And all of you are going to be connected with us right through your careers. So it's not just this summer and then you're gone. And next year, some of you will not be here, new people will come, and this program will go on because of people like you showing that it's really valuable and how it works. So thank you very, very much.
Thank you, Professor Raghavan, for those inspiring words. Now, without any further delay, we'll start with the presentations for today. So first up, we have the Astronomy 1 group, and we'll start with the first group, who's called Agronauts. So let's put our hands together for them. Where we have Ashwini and Meghna, and the title of their presentation is Marooned Off Vesta.
Good morning, ladies and gentlemen. In the past week, the students of Astronomy 1 have been received short science fiction stories where we had to create a problem and its solution and see if the problem given would actually be solved in the real world. So today, my partner Ashwini and I bring you a story of survival and resilience in the face of unimaginable odds. This story is called Marooned Off Vesta by Isaac Asimov.
Before we get into the story, Isaac Asimov is an American writer and professor of biochemistry at Boston University. He's considered one of the big three science fiction writers. A prolific writer, he wrote and edited more than 500 books.
Now, back to the story. 3 astronauts find themselves stranded in the vastness of space after an asteroid collision leaves their ship crippled.
With no hope of rescue in sight, the trio contemplates their proximity to Vesta, a distant asteroid. However, with only 3 days of air left, their chances seem slim.
Amidst broken pipes and damaged systems, they find relief in revelation of a vast water supply within reach.
Driven by the necessity to survive, Warren Moore embarks on a perilous journey through the debris-filled corridors of the ship.
Through sheer determination and resourcefulness, Moore manages to utilize the water supply as a propulsion system, steering their ship towards their potential salvation.
With their survival assured, the trio shares a symbolic toast, a testament to their unity and resilience in the face of adversity.
And so, against all odds, these 3 astronauts prove that even in the darkest corners of space, the human spirit can triumph.
While reading the story, we had many questions that we wanted answered. Now, we'd like to share our research with you.
Before we get into the questions, let us talk about Vesta. Now, as mentioned in the story, Vesta is a distant asteroid, which is the potential salvation for the characters. Vesta actually exists. It's the second most massive body in the main asteroid belt, which is located between Mars and Jupiter, which accounts for almost 9% of the total mass of all asteroids. And another special thing about Vesta is that it has a separate crust, mantle, and core, just like Earth. Now, based on the description, you might think that Vesta is such a huge asteroid, but once compared to our moon, you can see the size difference. Let's get back to the questions. Now, one of the most basic questions that come to mind is that, can water be a good substitute for rocket exhaust? Now, water itself is not a fuel, as it does not provide any sort of energy. But it does provide but it rather contributes the mass for the rocket engine for it to function effectively. This principle is centered on the application of force for acceleration, which is achievable through the expulsion of mass. By ejecting water, thrust is produced. Theoretically, this method is valid for propulsion purposes. Now, in the story, when Warren Moore creates a hole in the water supply, the water released immediately turns into vapor. This is because at 0 pressure, water turns into its gaseous form, that is, water vapor.
Now, the story we were given for our project is actually only one chapter from a much larger story written by Isaac Asimov. In the entire story, he mentions the escape velocity of Vesta. But before we get into that calculation, what is escape velocity? Escape velocity is the lowest velocity a body must obtain for it to escape the gravitational field of an astronomical object. The formula we use to calculate the escape velocity is root over 2gm upon r, where g is the universal gravitational constant, m is the mass of the object, and r is the radius of the object. We get this by equating the kinetic energy of the body and the work done against gravity. We get this equation through the conservation of energy. Now, what is escape velocity of the Vesta asteroid? Using the same formula, we take g as the universal gravitational constant, m as the mass of Vesta, and r as the radius of Vesta. Through the formula, we get the value of 360.55 meter per second. Now, to put this value in perspective, we all know that the speed of sound is approximately 330 meter per second. Now, to check the calculation and the value we received for the previous calculation, we calculated the escape velocity of Earth using the same formula, as you can see here. We got the similar, we got a close to accurate value. Now, In the story, we were told about the apparent size of Jupiter and Saturn as seen from Vesta. So we decided to calculate this apparent size using the information provided to us in the story and also what the accurate value would be. Let's compare it.
Before we get into that, this is a formula that we'll be using. It's called S is equal to R theta. And how it is derived is it's basically basic trigonometry. So we have theta, which is this angle. R is the distance between the two objects, and S is the arc length. So using basic trigonometry, we get tan theta is equal to S by R. Now theta is such a small value that the tan can be removed. And by doing that, we get theta is equal to S by R, which is nothing but S is equal to R theta.
So to calculate the apparent size of Saturn, we take this one, sorry. Okay, so to calculate the apparent size of Saturn from Vesta, we take S as the diameter of Saturn, 116,464 kilometers. We take R as the distance of Saturn from Vesta, approximately 6.3 AU or 9.42 into 10 to the power 8 kilometers. We use the formula like Meghna, the one we derived, theta equals S upon R, and we get 0.0069 degrees. Now that was the accurate value of what the apparent size should be. This is the apparent size using the information given to us in the story, where theta would be, the apparent size of Saturn from Okay, so I'll just okay. So we take theta, so using the information given to me now. Theta, the apparent size of Saturn from Vesta, which is compared to the apparent size of Venus from Earth, we get theta as 66 arc second or 0.018 degrees. Now this value 0.018 degrees is approximately 2.6 times larger than the accurate apparent size we got, which shows just how inaccurate the information given to us in the story actually is. So that was Saturn. Now the accurate apparent size of Jupiter from Vesta, we use a similar method. We take S as the diameter of Jupiter, 139,820 kilometers. We take R as the distance of Jupiter from Vesta, approximately 2 AU or 2.99 into 10 to the power 8 kilometers. We use the same formula, theta equals S upon R, and get the value of 0.026 degrees. That was the accurate apparent size. Now, through the information given to us in the story, the apparent size of Jupiter, as seen from Vesta, is compared to a small p in the sky. So it's quite a creative method. We take S as the diameter of a pea, which we get by dividing the average length of a pea pod, approximately 6 centimeters, by the number of peas in a pod, 8. We get the value of 0.75 centimeters. We take R as the average length of a human arm, as if we're holding the pea up in the sky to compare. We get 73.66 centimeters. Using the same formula, theta equals S upon R, we get the value of 0.57 degrees. Now, to put this value in perspective, 0.57 degrees is approximately the same as the apparent size of the sun as seen from Earth, 0.5 degrees. Now this value 0.57 degrees is approximately 20 times larger than the accurate value we calculated, which once again shows how inaccurate the information provided to us in the story is.
So in the story, it's mentioned that the apparent sizes of Jupiter and Saturn as discussed in the question. Now this image shows how it would look like from Vesta.
So the past 4 weeks we have spent learning about astronomy through the guidance of Professor Shushan Konar, Professor Saurav Mitra, teaching fellow Umang Kumar, and our TAs Tanuvi, Advay and Gagan.
Throughout the weeks, we have learned information that goes beyond the bounds of our solar system. All of us enjoyed the assignments, the short story reviews, the information that we learned about dark matter, stars, galaxies, and whatnot. We even learned how to fake colorize various galaxies. Here are 2 images. Now, the X-ray images were taken from NASA's Chandra X-ray Observatory, which is named after the Indian physicist Subramaniam Chandrasekhar, and was edited by us. Even you can do this using an app called the GIMP app. Overall, it has been a mesmerizing journey being a part of the Astronomy 1 course and the Lodha Genius Programme. Thank you.
Thank you so much, guys. Now we'll take up questions.
So how did you what was your inspiration behind deciding to calculate the apparent size of Jupiter with a P and an R? What was your thought process when you thought of this?
Our project was basically, we were given a short story and we had to analyze the solution provided in the story if it would hold out in the real world, as Meghna had explained. So one important part of the chapter we were given was the apparent size of Jupiter and Saturn. It was only one line, but it would have made a really big question. So, and it was also quite creative how we found it out. So that was our thought process.
I have a question. So what factors determine the escape velocity?
So, like I explained, the escape velocity is a velocity that the ship, let's say a rocket ship, must obtain to escape the gravitational field of an asteroid or planet. So this actually depends on the distance of the boundary of the gravitational field from the center of, let's say, the planet. So if there's a greater distance, then of course the gravitational pull will be a little less, so the escape velocity value can be a little less. But if it's a shorter distance, gravitational pull will be a bit greater, so the escape velocity you'll have to obtain will be greater.
So in that part in which you said theta equals S by R, wouldn't S be curved and you would have to differentiate to
Yeah, so we get the value using a spherical object, like a planet. So there S will be the arc length we take, but because we're seeing it like, let's say I'm calculating the apparent size of the sun. There S, we can't get a curve because it's such a small object we view, it'll seem like a straight line, which is why we take it as the diameter in the question.
Essentially you're differentiating.
Differentiating, sorry?
Essentially you're differentiating.
Yeah.
Okay, thank you.
You're welcome.
Hello? Okay. I have a question. How do the rockets keep the fuel liquid?
So the tanks that are used to store the fuel, in this case it was water, but usually the tanks that are used to store the fuel, they need to be lightweight yet sturdy enough to contain these heavy gases, suppose helium, which will help in naturally pushing the fuel into the supply line, and it also requires insulation to keep the fuel liquid. Any other questions?
Hello, I really loved your presentation. It was really enthusiastic and interesting. Just a question that you used any references to get the value of any particular, like all of them, to the calculation and all? Have you used any references and such?
So a lot of the values we used will be, the values we used, we took from the internet because they're pretty generic. Nothing we had to like recheck again and again to make sure it was right. Like the diameter of Saturn and Jupiter will be found on the internet pretty accurately.
Thank you.
Thank you.
Hello, okay. First of all, the presentation was great. It was really intriguing, and I love the way you sort of brought to life the story in the form of a presentation. So my question is regarding the apparent sizes. Like, how do you compare the the accurate value it should be and the value that you got as per the story. What made you decide that it's 20 times larger than it should be? What is the scale for that?
Okay, so I explained the process we got to find the accurate value and using the information given in the story. Do you want me to repeat that? Or? Okay.
No, I'm asking about the comparison.
Right. So the comparison can be made by just dividing the values. One is 20 times. It seems larger because so the value we get for Jupiter is 20 times larger in the sense that it looks like how we would look at the sun, how the sun would appear. That's how Jupiter appears. But the accurate value we get using accurate values it's a much smaller looking object. Thank you.
If you have any more questions, you can catch them up after this, okay? After.
Hi, Chintan. How are you? I'm supposed to introduce you.
Yes, okay.
So it's great. That was a very nice presentation. Thank you. So it's a great pleasure and an honor to introduce Dr. Chintan Vaishnav. And Chintan is the director and CEO of the Atal Innovation Mission, which I hope some of you have heard of. How many of you have heard of the Atal Innovation Mission? Good, that's not too bad. That's very nice, okay. So the Atal Innovation Mission was started in 2016. Yeah. And it was an unusual mission because it was started by a structure known as the Niti Aayog and not by any of our science or technology departments. And the reason it was started by a central structure like the Niti Aayog was it wanted to invert what science does with respect to society, not by a top-down approach that here is science, let's go and do something, but here is society and what can we do to spur innovation and spread that across the country into different sectors. And there could be no better person to drive that than Chintan Vaishnav. Chintan is what is called a socio-technologist who combines society's challenges and demands with the use of technology to address them. He's been doing that for many, many years in India. He's at the Massachusetts Institute of Technology, and he's on leave from there to direct the Atal Innovation Mission. The Atal Innovation Mission grew from 2016 on under the directorship of Ramanathan and his team, so there was a really terrific team. And Chintan has taken that on to spread Atal Innovation Mission in new ways. There are Atal Innovation Labs in schools all over the country, in different kinds of schools. There are Atal incubators and 2 or 3 other programs, which I won't get into now. And this is an extraordinary challenge to try and deal with innovation across the scale of the country, and across the scale of different kinds of geographical, social, and economic contexts. And Chintan and his team are doing an incredible job. And I'm sure that all of you will have a lot to learn from him, and he will have a lot to understand from your experiences. So over to you, Chintan.
Thank you so much. It's a great honor. I have to also add that Professor Vijay Raghavan was, when he, as a principal scientific advisor, was also on the board of Atal Innovation Mission. So he is also a part of the AIM family. So thank you. It's great to be here. I just had a quick glimpse of the first presentation and all the questions, really fascinating. And so happy that this is happening here. I'm here with 2 of my other colleagues, Shubham and Prachi, and they also work on the Atal Tinkering Labs program. In fact, Prachi is an intern with us, so you know, something that if you ever considered, we'll be happy to talk to you about. So, I mean, the Atal Tinkering Labs has been fascinating. We are learning a lot through them, especially so far with the 10,000 Atal Tinkering Labs, which are across 722 or so districts. So about 90% of India's districts have these labs. And more than 1 crore students have been influenced with this design thinking, entrepreneurship. What is most fascinating to me is that many problems that we never thought were problems are getting uncovered through these children. And they are teaching us how to think about such problems. Almost 20% of the problems they pick are very local problems. And that part is really fascinating. And then apply science and mathematics, etc., to it. I think I can give you some very fascinating examples. Let me give you one example. You heard in the news today, there's also more news about it. There were 40 people who died in a fire in Kuwait, in a building fire, right? That was because of carbon monoxide poisoning. They died silently. Last December, so one of the things we are doing is we're building 500 Atal Tinkering Labs in Jammu and Kashmir. Last December, we had a program where many of these teams came together in Srinagar. And some teams had built a carbon monoxide sensor and a motorized window. So you detect a certain threshold, and then you open the window. So although it's really cold outside, but at least you don't die from the carbon monoxide poisoning, right? This is a simple solution, super simple, right? But it's a problem that rest of the nation doesn't even think about on a daily basis. So nobody is going to solve this problem for them. So I think now you could do, there was one more example, and because we are talking about science here, I'll give that example. There was this 2 girls who had a big desktop, a platform like this. And then they had 2 poles on it, like these 2 poles, a little taller, like this, right? Like this. It won't hold, but you get the idea. And then they had piles of cotton around the poles. And on top of the poles, they had optical sensors. And then they had written an algorithm to compute the probability of flash floods in the villages down below. So depending on the tilt of this, the incline, depending on how much snow there is, depending on the weather patterns, depending on the rate at which it's melting, and so on. And then they're computing that when the summer comes, how likely it is that there will be a flash flood in this village. Right? Big problem. But a beautiful formulation, right? Obviously they didn't get it fully, they can't compute it fully. They need a lot more sort of sophistication in terms of the weather, in terms of the terrain, in terms of the water basin, all of that, right? But it's a beautiful problem to think about. As you can imagine, right? Through building of an app. It's very nice. I was very enchanted by it. But I think this program, a program like this, I feel, is really, really crucial for our country because it has the potential to retain the excitement and the wonder of science and mathematics, which I think is by and large, it seems to diminish as one gets more older and starts working, and different expectations are there from their workplaces and so on. I'll ask you a question. Let's see if I can prove it through a question. if you look at the medal tally of the Math Olympiad worldwide, right? Look at the medal tally of last 10 years. What is your guess? What is India's rank in the medal tally? What would you say? World number? Is it? How many people feel it's in top 10? India is in top 10. Okay, all right. Who feels it is? India is in somewhere between in the top 25? Okay, all right, great. Okay, how about who feels it is not in top 25? Okay, okay, great. The last group is correct. We're 27th. Okay, what is our population? What is our rank? So one more question, last final trivia, okay? In the last 10 years, how many medals we think India won? 100, okay? The number is 5. Last 10 years, okay? What about, who's the closest nation to us in size? People, China. How many did they win? 51. 51, okay? So that as they say, thus proven that this is the case, okay? I teach, Professor Vijay Raghavan said, I teach at MIT. One of the common experiences we have is when we start to teach, so I teach a subject called system dynamics. And system dynamics takes simultaneous differential equations, control theory, and it applies to human systems, like organizations, like nations, like states, districts, whatever, you know, where people work. When we start teaching it, generally there are these senior managers in the room. It's a smaller group generally than this. And then predictably, within the first hour or so, some or the other manager pulls out the phone, starts looking at it, and walks out. And when they walk out, I walk out behind them. And then I usually see them not really talking on their phone. And I ask them, why did they walk out? And they will say that, you know, I'm so far away from mathematics. The first equation you show, half the people turn off, you know? And they say, I'm so far away from mathematics, but don't bother me with this. You tell me when the discussion is on, I'll come, whatever. So we cajole them into coming and saying that, you know, it's not that hard. You've done it when you were a kid. Come on, we'll do it together. So we sort of bring them in. And then finally, by the end of a couple of days, they are happily going along and so on. But I think that's what happens to people, right? And I think camps like these are a turning point for such negative trends. So I hope you make the best of it. Again, you know, you're always welcome to Atal Innovation Mission, Atal Tinkering Labs, and so on. And I look forward to more presentations and learning more from you. Thank you very much.
Thank you so much, sir. Next up, we have the Astronomy 1 group, which is called Icarus Explorers, where we have Netra and Rutuja. Can we have a huge round of applause for them?
Check. Check. Yeah.
Check.
The hottest piece of real estate on our solar system. A remarkable way to describe an asteroid close to the sun, and one that could only be thought up by the brilliant mind of Arthur C. Clarke. This futurist, TV show host, and undersea explorer wrote the science fiction story which we present today, Summertime on Icarus.
First published in Vogue in 1960, the story centers around an engineer stranded on the surface of asteroid Icarus. His travel pod is damaged and he cannot communicate with his team. He must get back to the ship before daytime begins or risk being burned to a crisp. He is overwhelmed by the fear of dying all alone on the asteroid. Fortunately, his colleagues arrive to rescue him, and he eventually escapes after battling for hours on the scorching surface of Icarus.
As we were reading this story, we came across many interesting scientific concepts. We decided to do some research, so let's see how much of the story is fact and how much is fiction. First, does the asteroid Icarus actually exist? Yes. Icarus is a stony, mid-sized Apollo-class asteroid. An Apollo-class asteroid is one that's very close to Earth. Its perihelion distance is less than Earth's aphelion distance. It was discovered in 1949 by the astronomer Walter Baade, and it's interesting because it crosses Mercury, Venus, and Mars at different points in its orbit. We'll discuss its orbit later. It has many special features. Now, it'll next pass within 9 million kilometers of Earth in 2043. The name Icarus comes from a Greek myth about a boy who flies too close to the sun. It's a fitting name for this asteroid because in the story, the asteroid is within 17 million miles of the sun. What is meant by the eccentricity of Icarus's orbit? The eccentricity of any elliptical orbit is a measure of how much it deviates from a circle. Here you can see a scale of eccentricity. As the orbit becomes less and less circular, it's considered more eccentric. Now, this means, since Icarus has a very eccentric orbit, at some points of the year, known as the perihelion, it's very close to the sun. And then at another point of the year, the aphelion, it's very far from the sun. This eccentricity also affects the velocity of Icarus. By conservation of angular momentum, mass times velocity times the radius of its orbit is a constant. With the mass of Icarus being a constant, the velocity varies inversely with the radius of the orbit. This means that when Icarus is close to the sun, it's very fast, while when it's further, its velocity is a lot lower. Now, how do we calculate the rotational velocity of Icarus? First, let's take some of the data we were given in the story. The story tells us that the diameter of Icarus is 2 miles and the duration of a day on Icarus is 4 hours. Using this, we can just divide the circumference of Icarus by its day duration and we get 1.57 miles per hour as its rotational velocity. The story later tells us that the rotational velocity of Icarus is 1 mile per hour. So this is pretty close to the value we got. Now, let's use actual data. The actual diameter of Icarus is 0.87 miles, and that's the actual duration of a day on Icarus. We use the same formula, and we get 1.2 miles per hour as the rotational velocity, which is much closer to the value in the story. So here, the story is pretty accurate. We can also calculate the distance of Icarus from the sun with the values given to us in the story. The story tells us that the apparent size of Icarus the apparent size of the sun from Icarus is 30 times that of the sun from Earth, which is 30 times 0.5 degrees, 0.2618 radians. Now, to calculate the distance between Icarus and the sun with this value that we got, we use S equals r theta. You've seen the derivation already. And applying this formula, we get the distance of 3.3055 million miles. The story tells us that Icarus is currently 17 million miles away from the sun. Now, these values may seem different, but when we study astronomy, we learn to make approximations. And since the order of magnitude is the same, we can say that the story is more or less accurate.
Now let's see if it is possible to land a probe on the surface of an asteroid. Well, to answer the question, yes, it is. In 2001, NASA's Changemakers spacecraft became the first probe to touch down on the surface of an asteroid. The mission was designed to study the near-Earth asteroid Eris from close orbit over a period of a year. The primary scientific objectives of NEO were to return data on the bulk properties, composition, mineralogy, morphology, internal mass distribution, and magnetic field of Eris. This data will be used to help understand the characteristics of asteroids in general, their relationship to meteorites, comets, and the conditions in early solar systems. Other missions that also contributed to the exploration of asteroids are Japan's Hayabusa 1 that delivered sand and dust grates from asteroid Itokawa in 2010. OSIRIS-REx was the third mission in history to collect a sample from an asteroid and featured the most comprehensive suite of instruments ever flown on an asteroid research mission. The spacecraft's 2 years of scanning scanning the surface of asteroid Bennu and brief sample collection touchdown showed scientists how little they know. So in the story, the astronaut Sharon shields himself from solar radiation using something known as a sunscreen. Not a sunscreen, a sunscreen. It's basically 2 thin metal foil sheets that protect them from solar radiations. However, in reality, astronauts use something known as a visor that blocks off UV rays. The rest of their body is protected by a spacesuit, and the spacesuit insulation technology protects astronauts from extreme high and low temperatures in space. The story also claims that the gravity on Icarus is 10,000 times weaker than that on Earth. To check this claim, we can use the formula of acceleration due to gravity equals to gm by r square. G here is the gravitational constant, m is the mass of Icarus, r is the radius of Icarus. So if this claim is true, then the value of g should be equal to 9.81 into 10 raised to minus 4. However, after doing the calculations, we get the value of g to be 1.87 into 10 raised to minus 5, which is a lot more than 10,000 times weaker. So the value of radius that we use over here is the one that we got from the story. So we also did a little research and we got the actual value of radius to be 700 meters. So after using this radius, we get the value of g to be 9.9 into 10 raised to minus 5, which is also a lot more than 10,000 times weaker. So hence we can say that the claim that they made is false, and also the radius that they have used is also incorrect.
These are the sources we used for our research in case you want to look into them. Before we conclude, we'd like to thank our amazing astronomy professors and TAs. We could not have done this without them. We also want to thank the LGP team and Ashoka University for this incredible opportunity.
In the end, although the story is a work of fiction, some aspects of science are depicted accurately in it. What's even greater is that this short story was written in 1960, long before the first probe landed on the surface of an asteroid. The story captivated us, and we had an incredible experience learning about the mysteries of space while reading it. Thank you.
Thank you, guys. We'll take up questions now.
Hello. So you said that astronauts use visors, and the person in the story used 2 aluminum foils to protect himself. So how is it that he can see things using the sun's light, but he's not exposed to radiation?
So we have tried proving that it's incorrect. 2 thin metal foil sheets cannot protect you from sun solar radiation, so that's not something that is practical and used. So yeah, that was something that is not correct in the story.
Okay, because I've seen one-way mirrors which reflect back in wherever there's more light. So that would be one way, but then aluminum foils, I'm not too sure. And my second question is, you said that the order of latitude, if that is the same, you would assume it to be fairly accurate. But if you're talking about, say, 1 mile and 1.5 miles, it's nearly a 50% increase. Why would it be, I don't consider that to be accurate, because it's like almost half
Okay, the thing is we're not talking about 1 mile and 1.5 miles, we're talking about millions of miles. So when it gets to millions, the values, honestly, it doesn't matter. It's like 5 times the value, and we don't really see that as a huge deviation. It's not completely accurate, but it's approximate.
Fair enough, thank you.
Also, you said aluminum foil. It's not aluminum foil, it's just metal foil.
Hello, good presentation. So I noticed that you claim that Icarus has a high orbital eccentricity because it crosses the orbits of Mercury and Mars. And you told that the apparent size of the Sun is about 30 times, that's what the author claims. So you found an accurate apparent size. So is that for at the perihelion, aphelion, or is it averaged?
So that's at a distance of 17 million miles from the Sun, according to the story. I'm actually not sure if this is at the perihelion or aphelion, because I'll have to look into the values for that, but you could check and find. Could also calculate it just by like looking at the length of the orbit and then finding the time taken, the orbital period. I don't have the exact values, but it's quite a simple calculation if you have the data.
Yeah, and my second question is that if a satellite probe has to land on Icarus, it has such an elliptical orbit with a high eccentricity. So it is very hard for an object to land on an astronomical object which is moving in an eccentric orbit, as we've seen in many cases. So how did the probe land on Icarus accidentally?
Oh, so here the probe has not landed on Icarus. That was in the story.
Yeah.
The missions that Rituja was talking about, it was on different asteroids, not Icarus. Yeah.
No, I was mentioning the story. Like, was it a...
Okay, so the story is science fiction. So that part could be fictional. They don't really explain how they did it. But yeah, that was just one example in the story. In real life, we were talking about other missions.
Okay, thank you.
All right, thank you guys. Thank you for your time. Now we have the third group from the Astronomy 1 module, and we have Moonathon runners, where we have Mansi and P. Tokyo. And the title of their presentation is Walk in the Sun. Can we have a round of applause for them?
Hello.
Hello. Hello. Hi everyone, this is Fairojum Tokyo Singh, and good morning. So this is my project partner Mansi, and we are working on a science project and in the field of astronomy. So our project is basically based on science fiction story named as Walk in the Sun, written by Geoffrey Landis, and science fiction author. And to look upon the story, I like to request Mansi to just view it once.
Yeah. So the story Walk in the Sun is written by Geoffrey Landis. He is an aerospace engineer and an author. Currently, he is working with NASA. So our story begins when Moonshadow, an orbital spacecraft, which was never meant to be a landing vessel, crashes on the moon. Trish Mulligan, the only survivor, she found an undamaged EVA spacesuit powered by solar cell. To call for help, Trish needs to get the radio and 3-foot antenna, but it is difficult to carry and hard to set up. But also, she had to climb up the mountain. She has only 5 minutes before Earth goes below horizon. But that's enough for communicating her situation. To get out of the situation, she needs to be in contact with sunlight so that she can survive on the moon. In the low gravity, this posed no real problem for walking. She did not feel tired. When she checked her readout, she realized that she had been walking for 20 hours. After walking a distance of few hundred kilometers, she was in mere spumens. In 6 days of travel, she had walked a quarter of the way around the moon. She passes through Tranquility Base, but does not see the historic Tranquility Base landing site. She kept on walking. When she was walking on surface of the moon, her footsteps struck sparks from the rocks, and behind her footprints glowed faintly. She realized that it was tremoluminescent glow. Trish was finally rescued after 30 days of survival on moon. She had traveled 11,000 kilometers on moon. The crew shuttle launched through heavy fog to join their rescuer in orbit. Now I hand over the mic to Tokyo to further.
So finally, let's look upon the questions we came up with. And aside from the science fiction story, we have found out some basically real life event which actually can be proven. So here are the questions we had come up with, and let's discuss and elaborate the answers. The first is calculation of day and night, duration on moon as compared to Earth. Second is angular size of Earth as seen from the moon. Thus moon also has its own map, phenomena of tremoluminescent glow. So let's ponder upon the first question. Calculation of day and night, duration on moon as compared to Earth. Earth rotates on its axis approximately around every 24 hours, and the day and night length is also same. And as we take the average 12 hours of day and 12 hours of night. And let's look upon the moon. Moon's rotation periods and orbital periods is almost same. There is 27.3 days. So when we divide it into day and night, it is at 13.65 Earth days and 13.65 like Earth days only. So the next question is angular size of Earth as seen from moon. So the question is, so when Trish was just 5 minutes before the horizon, as she has told, the Earth which was visible to Trish was at some angle. So the formula to find the angle theta is equal to length of the arc, that is S, or the diameter of the Earth. Actually, the formula has been already told by them. So let's just look upon how we derive it. Theta is equal to S divided upon R. Here it is. And so distance between Earth and Moon, the R is equal to 3.84 into 10 to the power 5. That is 3,84,400 kilometer. And distance of diameter of Earth, that is S, is 2 into 6,371. The 6,371 is the radius, so it's just double it. So theta is equal to approximately 1.92 said 2 degree, which has been seen from the moon, like the Earth, the image of the Earth. And so now there is the comparison of size of Earth seen from the moon. So actually, when we see moon from the Earth, it will be 4 times Earth as 4 times the size of moon as we see from the Earth. Like we see moon, like it is so much small, but we will see 4 times as big as moon if we see Earth from the moon. Okay. So the next question is up to you, Mansi.
The next question is, does moon also has its own map? Yeah, and there are some locations like Mare Spumans or the Sea of Roth. It is a lunar mare on surface of the moon. It is one of the many basaltic plains formed by ancient eruptions. And the second one is Dionysus. It is a lunar impact crater that lies on the western edge of the Mare Tranquility Base. It is the site on the moon where humans walked for the first time. On 20th July 1969, Apollo 11 crew members, Neil Armstrong and Buzz Aldrin, landed their Apollo lunar module Eagle. Next slide, please. So this is the Tranquility Base. This is the Dionysus. And the next question is phenomenon of tremoluminescent glow. It is a fascinating phenomenon. where light is emitted when certain materials are subjected to mechanical stress, such as rubbing, crushing, or friction. This light emission occurs due to the breaking of chemical bonds in the material when it is formed. The term triboluminescence comes from the Greek word tribene, which means to rub, and the Latin word lumen, which means light, and its examples are cutting a diamond and opening sealed envelopes. Next slide. These are some pictures of triboluminescent glow. And the next, we have done this colorizing image. It is done by using an app called GIMP. This app is very interesting as it provides many editing features.
So throughout this whole journey in Ashoka, I learned a great learning experience and exposure with top brilliant minds like you guys. And I would like to thank Ashoka Group, Lodha Group, Ashoka University, for providing us the opportunity to foster our skills and knowledge. Our heartfelt recognition goes to our astronomy professor, Susan Koner, Saurav Mitra, and teaching assistant Umang Kumar. Lastly, but not the least, also, can you please give a round of applause to the hardworking TAs? So they just helped us to enhance our skills. So that's our slide. Thank you, everyone.
Hello. Thank you, Mansi and Tokyo. We'll take questions.
Hello. So I have
Hello,
two
hello.
questions.
Is it
They're
working now?
related. So you said that the size of the Earth is 4 times that of the Moon.
Yes.
So did you mean that in a relative scale, that is as Moon seen from Earth and Earth itself? Or did you mean it as in a relative scale of space-time in which you measure the distances, the diameters of both the Earth and the Moon, and then you calculate what percent of the diameter is of the Moon? And also, if that is true, then how did you use? Did you use Euclidean geometry, or did you account for curve in space-time?
Okay, so actually we know the radial diameter of the Earth and the Moon, right? So we've just taken the approximate numbers, answers. We have just found out that it's 4 times the diameter of the Moon. So basically, when we see the Moon, right? When we see Moon, like a Moon from the Earth, it's small. But when we actually see Earth from the Moon, like it will be 4 times the size of Moon as we see from the Earth. Like we have seen the full Moon in the night, it will be 4 times as much as Moon, like the size of Earth when we see from the Moon.
How did you calculate the size of Earth, size of Moon from Earth?
Because we have just taken the ratio of the diameter, right?
Okay, and size of the
But-
Earth from the Moon using that.
Yes, yes. But there's also some difference, like there is atmospheric dispersion and all, refraction and also. Thank you.
Yeah, so I had a question. What other natural phenomena can be observed from the moon besides the triboluminescent glow?
Can you please repeat it?
What other natural phenomena can be observed from the moon besides the triboluminescent glow that you said?
There can be many things, like, but there is no organisms and species live in there. But when the trees actually work there, the friction which she has created by rubbing their leg on the moon, it has actually created the triboluminescent glow. Just like when we take our clothes and it matches, like it sparks with our hair, some sparks it came like the force of friction. So it's that only.
Okay, thank you.
All right. Thank you, Tokyo. Thank you, Mansi.
Thank you so much, guys.
Next up, we have the last presentation of the Astronomy 1 project. We have Chaitanya, our solar sailor, and The title of their presentation is The Sun Jammer.
Okay. Good morning, everyone. Today, I, Chaitanya, from the Astronomy 1 course, will be presenting my research on the story The Sun Jammer. The Sun Jammer has been written by Arthur C. Clarke and has been taken from a collection of stories called The Wind from the Sun. Now, something our astronomy professors wanted to inculcate in us was that we should know why things happen instead of what happens, and so that we can apply it in different places. And I think this has been perfectly captured by this quote by Isaac Asimov, which says, "The true delight is in finding out rather than the knowing." So I'll divide my presentation into 3 parts. First, I'll talk about what the story was and give you a brief. Then we'll look at how scientifically accurate it is. And if you have any questions, you can ask me at the very end. So before the race starts, our protagonist is sitting in low Earth orbit, and he's finishing his last-minute checks before the race begins. The crafts that they're using are called solar sails. Solar sails use the energy from the sun to propel themselves without using any internal fuel source. So this is him completing the pre-flight checks. And once the race begins, the story alleges that the crafts start accelerating by an acceleration of g by 1000, which is approximately 0.01 meters per second. However, a lot of mishaps occur, and a lot of the ships are, they either collide with each other or they get destroyed, and there are several malfunctions. And so at the end, we are only left with the protagonist, Merton, and a Russian team that are still in the race. However, the race needs to be abandoned because of a solar storm, and the ships do not have radiation shielding. So this could have led to them getting severely hurt, and the damage on board could have been, significant. So one of the first things that pops out is, are solar sails really possible? And can solar radiation pressure be harnessed? And the answer is yes. So this image that I have behind me is a picture of the solar sail 2, which was sent into orbit in 2019 by the Planetary Society. And it was able to correct its orbit using only solar radiation. I think it re-entered the Earth's atmosphere in 2020. So I've got 3 pictures here of potential solar sails. The first one that I have over here is an artist's representation of what solar sails might look like and how they might work. And as you can see, the sail is much larger than the actual probe that it's carrying. And it's got a hole over here because of the fundamental property of how circular mirrors, spherical mirrors reflect light, which is when light strikes the pole, it reflects back perpendicular to the pole. And that could have ended up reflecting onto the craft, and due to overheating, the craft would have malfunctioned, thus compromising the mission. So that's why they've got that hole over there. Now, this is what an artist thought the solar sails could look like, but the blue image that I have over here is what actually, what our technological capabilities actually allow us to do. This is because these are easy to manufacture and send into space, because they require relatively low volume. So the first things that we'll check is how high is the solar pressure at the distance that the Earth is from the sun, and is the acceleration that the story talks about even true? Now, while I was reading a few research papers, I came across a formula which said that the solar pressure is dependent on the distance from the sun squared and the intensity. And what we see here is a plot of that. And I've got 3 lines here representing the distance from the sun for Mercury, Venus, and Earth, respectively. So we all know the formula mass times acceleration is equal to force, and force divided by area is the pressure. So once we calculate the pressure, we get 10 to the power minus 5 Newton per meter square. And the story says that the solar sails have an area of about 50 million square kilometers. Converting that, we get 5 into 10 to the power 13 meter squares of solar sail. Now, if we if we multiply the two, we get a force of 5 into 10 to the power 8 kg meter per second square. We've all seen these SI units, right? So now if we assume the mass of the probe to be 5,000 kgs, which is the typical mass of a short re-entry capsule, we find that the pressure is approximately 10 to the power 8, and that exceeds the acceleration that the story was talking about. So the story greatly underestimates what the acceleration could have been, and this is great for us because we can now harness this energy to send out probes by using less fuel, onboard fuel. Another problem that the story talks about was cold welding. So cold welding generally occurs at very low temperatures where due to friction, the oxide layer of the metals wears off and the pressure applied leads to them fusing together. And that led to a jam of a ball bearing in one of the spacecrafts. So how could we prevent this? And I was looking up on how we could, and it said that metal alloys that do not have carbon are more prone to cold welding than alloys with carbon. So the problem with that is steel, despite having carbon, does in fact get cold welded. So a solution to that could be using tungsten carbide, which is suitable for dealing with the pressures that it needs to in space. In the story, the Martian vessel was spin stabilized, and they were not, due to this, they were not able to change their direction, and they lost control of their craft. So this immediately reminded me of the Explorer 1 satellite, which was the first satellite sent into space by the United States. And this too was spin stabilized, and it had 4 antennae. And this led to the loss of kinetic energy. Now, let's just talk about what spin stabilization actually is. Spin stabilization is when a craft rotates along its longitudinal axis so that it does not deviate from its path. And so that's what they've done over here. But the antenna led to a loss of kinetic energy because they were flapping around. So since their configuration was changing over and over again, they lost a lot of kinetic energy. And the craft ended up rotating end on end. So this was a problem. But is this possible in the Martian craft? The answer is no, because even though they were spin stabilized, there was very less loss of kinetic energy, net loss of kinetic energy, because they were connected to the solar sail, which was propelling them forward. So since there was no free strings that could lose kinetic energy, the problem that the Martian satellite probably faced was that they were not able to maneuver their craft properly. My bad. So due to the solar storm, instead of disconnecting the sail from his craft, Merton decides to abandon his craft and let it go to the outer reaches of the solar system. It was calculated that the craft would exit our solar system within a few years and would become the fastest man-made object, which I think is really beautiful and shows how far the human race can actually go. Thank you, and if you have any questions, you may ask me now.
Hello. So I didn't understand the cold welding part, because if a metal contains a large amount of carbon, why would it be less prone to oxidization? Also, why does oxidization necessarily lead to expansion?
Okay, so what happened, I'll just go back to that slide. Right, so cold welding occurs due to, so basically, you know how metal lattice is, delocalized. Electrons in the metallic lattice are not localized. So they're free to move around. And so when they don't have an oxide layer and we bring two metal pieces together, due to the pressure that's applied to them, the two metal pieces fuse, and the oxide layer is basically preventing that from happening. So in space, since there's no atmosphere, no oxide layer can be formed to replace that, and that's why cold welding occurs. And now what carbon basically does is, it helps with that fusing to happen. It prevents that fusing from happening.
Hi, I loved your presentation. You talked about the movement of solar sails, right? So I wanted to ask how they move and what material and shape is best for the efficiency.
Okay. So typically for solar sails, they use a very thin reflective sheet. It's about 6 microns thick. So it needs to be very thin so we can minimize the mass and get a higher acceleration from the force that we get. And they work by getting their momentum from photons. So light basically reflects off from the sail, and the momentum of the photons is transferred to the sail. This allows the sail to move forward, and that's where the energy is coming from.
It was a very nice presentation, but I had one doubt. Like you told, there was a solar flare, coronal mass ejection. So in that case, where was the spacecraft exactly? Was it in low Earth orbit?
So it was on the way from the Earth to the Moon, and it was the solar mass ejection was directly aimed towards Earth, and it could have ended up, due to radiation poisoning and all of that, that could have harmed humans. So that's why they had to abandon the race.
But I've heard that due to the Earth's magnetic field, where was it exactly from between Earth and Moon? Like,
it has not been specified in the story, but see, the Earth's magnetic field is protecting the surface, but there's still a little bit of radiation in the atmosphere. So, on the outer reaches of the atmosphere. So that's why they had to abandon race. Also, yeah. So.
Yeah. You're telling?
So, it's very radiation is very. Obviously everyone knows this radiation is harmful, but their crafts did not, they had to minimize the mass, so they did not have radiation protection equipment on board.
Okay, thank you.
You talked about both artistic and technical probe in the slide. So are they, how are they different from each other?
Okay, so the main difference here is, over here, the probe is connected to the sail using wires and rods, and so it's basically, there's a lot of tension in here, and it could also lead to a lot of failure points. Like, if this gets detached, now you're not able to properly maneuver this. Here, that's not a problem, and so this is basically called a CubeSat. It's very easy to manufacture in colleges and all that, and it's easy to transport to space because this can be folded back and sent using rocket launches. This is very large, like 50 million kilometers. It's very hard to fold that up and send that into space. So this needs to be constructed in space, and a lot of micrometeorites could end up passing through this and harming the sail.
One last question.
Absolutely love your presentation. It was really nice. But my question is a bit out of context. Like, you are the only one in the whole group of Astronomy 1 that presented like solely. How many or what kind of challenges did you encounter while preparing for the presentation, and how did you come up with the solutions for them?
So I didn't really face a lot of challenges. Obviously, the workload was a little greater on me, but I had the help of my astronomy TAs and my professors. So I got a lot of help from them, and that's how I was able to manage it.
Thank you so much, Chaitanya, for that presentation. Can we have a round of applause for Chaitanya? So, as we end the Astronomy 1 project presentations, we would also like to thank our faculties, Dr. Sushan Konar and Professor Saurabh Maitra. So can we also have a round of applause for them? Now we move to the second Astronomy 2 projects presentation. So we have our first presentation by the Star Chasers, where we have Nishant Kumar and Divya Solanki, who are going to present, the title of the presentation is Unlocking Secrets of the Universe. So a round of applause for them, guys.
Hello, we're the Star Chasers. I'm Nishant and she's Divya. And today we're going to be unlocking the secrets of the universe. And in this presentation, we seek to cover the most interesting aspects of what we learned in our Astronomy 2 project.
Okay, so Kepler's law of planetary motion. We would be very familiar to this law because they are so much important in astrophysics or in the physics. So there are 3 laws of Kepler which were discovered or invented by Johannes Kepler, who is a German astronaut in 1609. So the Kepler's first law states that all the planets revolve around the sun in an elliptical orbit, with having sun as one of the foci. So image here is obtained by us, which has 8 elliptical orbits of the planets and the helix comet with it. Okay, the second law states that the radius vector drawn from the sun to the orbit sweeps on the equal areas in the equal interval of time, and the areas are constant in this, as you can see in this image. Okay, the Kepler's third law states that the square of the orbital period is directly proportional to the cube of the semi-major axis. As you can see in this image, the semi-major axis and the semi-minor axis are having foci F1 and F2, and the graph shown here is of semi-major axis versus the time period axis.
So now I'll be talking about our field trip to the Aryabhatta Research Institute of Observational Sciences, or ARIES for short. While we were there, we visited something called the DOT, or the Davis-Still Optical Telescope. Now, this is the biggest optical telescope in India. It has an aperture of 3.6 meters, which means that the primary mirror, which is spherical, has a diameter of 3.6 meters. Now, it started operation in 2016, and it observes objects in 3 spectrums: the optical, the infrared, and the mid-infrared spectrums. The steel dome that covers the telescope, as you can see here, is 13 meters in height and 16.5 meters in diameter. So the primary objectives of the telescope are to study transients, which are astronomical phenomena that happen incredibly fast, and to track the positions of celestial bodies that go across our sky. The DOT is a Cassegrain type telescope, which means it looks somewhat like this. Now, light is collected through the aperture, and that is reflected off of the primary mirror over here. The light then gets reflected into the secondary mirror. From there, it's reflected into the eyepiece. So the light is collected, and we can see it through the eyepiece. Up to 3 instruments can be used and attached to the telescope. One of the instruments we saw was the TANSPEC. It's a spectrometer in the infrared and mid-infrared wavelengths. The telescope utilizes something called active optics. This means that it uses pneumatic actuators, or basically pistons, to deform the shape of the lens to make up for atmospheric discrepancies. It also has something called a derotator. This makes up for the shifting field of view caused by the altazimuth mount. So as you can see here, this is a picture of us in front of the DOT. And these blue supports, that's the altazimuth mount for the telescope. So you might have seen articles kind of like this. This is an article from Times Now that says, you know, there's an asteroid flying towards Earth at like 20,000 kilometers per hour. And it is kind of true. As you can see, this is from the NASA JPL website. The asteroid is, at its closest, going to be 4.4 million kilometers from Earth. Now, this may seem like a pretty big distance, but in astronomical terms, this is pretty small. Now, And it's clear that this is not going to hit Earth, or most probably. But what if it did? If it did hit Earth, we would be interested in the impact energy, and that would just be the kinetic energy. We know the formula of kinetic energy is half times the mass times the velocity squared. We know that density is just mass over volume, so we can substitute the value of mass as density times volume. So the kinetic energy formula boils down into that. We can then substitute a rocky density because we know the asteroid, which is called 2024 LH3, is rocky. And we assume it's spheroid or spherical. So we plug in the value of volume for that. The radius is around 80 meters. And we get this value, 6.8 into 10 to the 14 joules. Or in terms of kilotons of TNT, that's 164. So this is 11 times the energy released by the Hiroshima bomb, which was around 15 kilotons. So if this were to hit New Delhi, which it won't, but hypothetically, if it did hit New Delhi, everything within that red circle would be instantly annihilated. Now, to measure exactly how dangerous asteroids like this would be to humanity, we use something called the Torino scale. It's employed by astronomers all over the world. And as you can see here, it gives us a nice graph of kinetic energy versus the probability. And it's divided into zones. So as you can see, the red zones of 10, 9, and 8, those are reserved for asteroids that would pose the greatest risk to humanity. Now, because of its small kinetic energy and probability to hit Earth, 2024 LH3 is a 0 on the Torino scale, which means it poses basically no threat to us. But the highest that's ever been recorded on the Torino scale is an asteroid called Apophis, and it hit a value of 4.
This is the image of Ring Nebulae, which was processed by us in our astronomy classes. So in short, okay, the images taken by the telescope from CCD, which are charge-coupled device, are not that colorful or not that enhanced or interesting. So we used different filters and frames to make it more colorful and interesting, which enhances its characteristics.
So as you can see here, the nebula, this is called Ring Nebula. It's, this colorful object. It's something known as a planetary nebula, which means it was formed after the death of a star. And if you can see here, there's a really small dot in the middle. That's a white dwarf star, which is it's a remnant of the original star. So now we'd like to thank everyone that's helped us. We have our professor, who's sitting right over there. We have our TAs, Samit and Sanjana, and the interns that help us, and the Philip and everyone on the Ashoka Physics faculty, the Ares team that made it possible for us to visit them, and everyone at LGP, everyone behind LGP, especially Ms. Zambika and Mr. Kishore. Thank you very much.
Thank you, Nishant. Thank you, Divya. We'll take questions now. Any questions?
Hello, that was a great presentation. So I had 2 questions. First, how would you calculate the probability of impact of an asteroid, and how do you do the maths for it?
Sorry, what was your second question?
The second question is that how do you calculate the mass of an asteroid if you don't know the density?
Okay, so good questions. Right. So the probability of impact. Now, remember she talked about Kepler's laws. Now, the problem is it's very convoluted. We don't really know where an asteroid is. We have to kind of predict all of that, the size and the position. It's pretty hard to predict the exact value. So if you go on Wikipedia, you'll see the values are usually indicated with some sort of error. This is because we can never be sure of the fact, put in the exact values. So there's always going to be this probability involved. because if you're not sure about some stuff, well, probability arises. And for your second question, wait, sorry, what was your second question again? I forgot.
The density of the asteroid.
Right. So so we know mostly that most asteroids are either can either they can be broadly classified into rocky and metallic. So for here I just used some rocky density, which is probably very wrong. If you go to Wikipedia, you'll see it's maybe closer to 700 to 900 maybe. We'll just have to, try to guess what it's made out of based on something called the albedo, which is the reflectivity, the amount of light that's being reflected. So metal asteroids will usually have a higher albedo, which means they would reflect more light. And, that's how we would approximate the density. Yes, it would. Exactly. Again, the reflectivity, it also depends on how close it is to maybe sources of light, stuff like that.
Yeah, so I have two questions. Is this scale logarithmic? And also, what would the asteroid that wiped out the dinosaurs rank on the same scale?
Okay, interesting questions. Could you repeat your first question? Sorry.
So is this scale a logarithmic scale or is it?
So yes, you can see it's pretty much logarithmic as it's increasing by powers of 10 to the 2. For your question about the Chicxulub impact, I have no idea, but probably would be maybe 8 to 10, somewhere over there.
Okay, one last question.
So I wanted to say it was a very nice presentation, but I have a question. This asteroid LH3 would move in a certain orbit and at a certain velocity. So where is it currently, and will it return after a certain period of time with a higher velocity, which can cause it to move closer to Earth?
Okay, so for your second question, I have absolutely no idea. It could, it couldn't, I don't know. For your first question, so this is the close approach viewer on JPL. If you use, so there's a website called the Near Earth Object Earth Close Approaches website. You can just go there, you can find the current position, the closest it will reach Earth, or the closest predicted position it will approach Earth. All of your answers should be on the website. Thank you very much.
So next up, we have the second presentation for the Astronomy 2, where we have the Singularity Seekers, Ansh, Alithya, and Ram Pranav. Can we have a round of applause for them?
Hello.
Yeah, the title of their presentation is Exploration of Cosmos.
Hello everyone, we are Team Singularity Seekers, and the title for our presentation is Exploration of the Cosmos. So during the course of Astronomy 2, we covered several topics, such as geoprecession, orbits of minor and major planets, eccentricity, and several more, but today we'll be covering black hole formation in brief, International Liquid Mirror Telescope, escape velocity, and Schwarzschild radius. So in every class of our Astronomy 2 module, we used to begin with the astronomy picture of the day. So today's astronomy picture of the day is sunspots, which are displayed in this picture. This is a colorized and sharpened image of the sun which is composed of frames recording emission from hydrogen atoms. Every 11 years, sun is at its peak of solar cycle. And now this is the solar cycle 25, which is going to happen in July 2025. And this time, sun is very active, which will have like 110 sunspots, like around that number. And as you may have heard in news these days, the auroras are at its peak in the northern hemisphere, such as in the regions of USA. And this happens due to the large number of coronal mass ejections and solar flares from the sun. And solar flares are potentially dangerous because this may lead to radio or electrical blackouts if it were to hit the Earth. So these are the sunspots as we saw from Ashoka University's telescope through a solar filter. So as you can see through the arrows, these are the sunspots as visible in this image, as captured from this location itself.
Okay, so I'll be talking a bit about black hole formation. So basically, black holes are formed from dying stars. So at the end of the star's life cycle, it basically, all that remains is the star's core. And if this core is greater than 1.4 solar masses, then gravity will cause the protons and electrons, you can say, merge to form neutrons. And it'll become a celestial body known as a neutron star. And if this core's mass is greater than 2 to 3 solar masses, then the gravity will be so strong that it'll form this object we know as a black hole.
Now, as you saw that Ram Pranav just talked about the limits for the star to collapse into a black hole or a neutron star, we call it something known as Chandrasekhar limit, which was discovered by Subramaniam Chandrasekhar. And the current accepted value for Chandrasekhar limit is 1.44 solar mass, which is around 2.88 times 10 to the power 30 kilograms. So Chandrasekhar limit says that if the mass of the star exceeds 1.44 solar mass, then will turn either into a black hole or a neutron star.
So to understand some of the topics that will be covered in a few more slides, I'm going to be covering something known as escape velocity. And it's pretty much in the name. So escape velocity is the minimum velocity needed to escape the gravitational attraction of a body. Or in simple words, how much velocity you need to escape like any large object. And this is the formula for escape velocity, where escape velocity is equal to root 2gm by r.
Now moving on to the next topic, we'll be talking about the Schwarzschild radius. So Schwarzschild radius is the measurement of a radius of a body which determines if the body will become a black hole. So as you can see in this image, if the Schwarzschild radius, if the radius of the body exceeds the diameter of the body, then it is highly likely that it will become a black hole. And it decides the final fate of more massive stars. Now let's approximate the Schwarzschild radius using the escape velocity formula, which Ramran just gave, that is root 2 gm by r. So now we know that the maximum speed of any object is the speed of light. So we can take the escape velocity as the speed of light for the object to become a black hole, and on further calculations we get the Schwarzschild radius as 2 gm by r squared. Now let's imagine, like, if humans were to be a black hole, then what radius would they require? So on putting up the values of universal gravitational constant, which is 6.67 times 10 to the power minus 11, taking the average mass as 80 kgs and the speed of light as 3 times 10 to the power 8 meter per second, we get the Schwarzschild radius as 1.18 times 10 to the power minus 25 meters. There's the accurate value, and for a human body it is to 1.2 times 10 to the power minus 22 mm as evident in the calculation, and it can be compared to the radius of an electron. And for Earth, the Schwarzschild radius is just 9 mm, while Sun has a Schwarzschild radius of 3 times 10 to the power 6 mm. Since Earth is greater than these measurements, it hasn't yet become a black hole, but if it were to be a black hole, it has to be in this limit. Now let's see what density would human body require to again be a black hole. So we'll assume the human body to be a sphere. So the volume formula is 4 by 3 pi r cubed. And we get the volume as 7 times 10 to the power minus 75 meter cube. And we can further calculate density as 1.14 times 10 to the power 76 kg per meter cube. Now, if we talk about the Earth, Earth must be squished to a small ball of 9 millimeters, similar to a billiard ball or a bullet, to become a black hole, while keeping the mass constant, which is around 6 times 10 to the power 24 kgs. Now imagine how small would humans be if the density were very large, as large as 1.14 times 10 to the power 76 kg per meter cube.
So I'm sure we're all familiar with the optical telescopes that are used most extensively in the field of astronomy. But today, another thing we'll be talking about is liquid mirror telescopes, which is not as common, but has surely contributed a lot in advancements in this field. So the mechanism of a liquid mirror telescope is fairly different as compared to other conventional ones that use solid glass. Here, there is a reflective liquid that is used in a shallow rotating container that rotates at a constant speed. So the centrifugal force that is produced sort of produces a parabolic shape it gives a parabolic shape to the liquid, which is an ideal surface created for focusing light. Usually the liquid that is used in this case is mercury. Why mercury? Because of three main reasons. Firstly, because of its reflective quality. Mercury, we all know, is a largely reflective metal. So it reflects large amounts of light that is essential for capturing the images in space. Secondly, it has high density, which means when it forms the parabolic shape, when it is spun, the parabolic shape produced is fairly smooth, which makes it all the more ideal and essential, which also produces high quality images. And thirdly, it remains liquid at room temperature, which means it doesn't require external heating or cooling. So the three main advantages of liquid mirror telescopes are cost effective. So it is comparatively much more cheaper than optical telescopes, not only to construct but also to maintain. Secondly, easy maintenance. So it is fairly more easy to replace the liquid in the liquid mirror telescope in comparison to the optical telescope that requires recoating, which is also more expensive, like I mentioned earlier. And thirdly, high optical quality. So like I talked about the high density of mercury, because of which the surface produced is fairly smooth and produces high quality images, and which gives, because of which liquid mirror telescopes often produce a more accurate image as compared to an optical telescope. Two limitations of the liquid mirror telescope is firstly, it has a fixed zenith pointing. Because of the fact that it uses liquid, it doesn't enable us to tilt the telescope, which means it has to be kept perpendicular to the Earth's surface at all times, which is why we can only observe objects straight above head, which is the zenith. And secondly, it is environment sensitive, which means it can be disturbed or affected by vibrations or air currents, which is why liquid mirror telescopes are oftenly constructed in remote places. An example of the liquid mirror telescope that is very notable is the only current liquid mirror telescope which is active in the world at the Aries Devastal Observatory. Its lens is a 4 meter, its lens has a 4 meter long diameter. Our Astronomy 2 module kids were very fortunate to visit the Aries Devastal Observatory just recently through the course of this LGP program, where we not only saw the liquid mirror telescope, but also the Devastal optical telescope, which is currently the largest in India. It is a 3.6 meter, it has a diameter of 3.6 meters. So this is our entire astronomy experience summed up in a few pictures here. And the experiences that we got the opportunity to be part of was incredible, because not only did we witness such phenomenal objects in India, but also got to be part of really exciting observations at the Aries Nainital campus. And we're more than grateful to our astronomy faculty, Sir Ashwin Shekhar, and our TAs and interns, as well as the LGP team, for giving us this opportunity.
Thank you, guys.
Thank
you. We'll take up some questions now.
Hello, that was a very nice presentation. I had two questions regarding liquid mirror telescopes. So firstly, you said that there's a rotating dish. So won't the rotations induce vibrations in the mercury and then light will be distorted? And secondly, how do you angle the liquid mirror telescope without the liquid spilling out?
Okay, so I'll take your second question first. To answer that, like I mentioned, the liquid mirror telescope, one of its limitations, in fact, is that it has a fixed zenith pointing, which means it's kept perpendicular to the Earth's surface at all times. So it is not angled in only because tilting cannot be done. And could you repeat your first one? I'm sorry.
The first question was that if it's rotating, then won't that cause vibrations in the liquid?
No, the motor that is used rotates at a constant speed, which is why it produces a parabolic shape that stays constant and is not disturbed.
That the speed of the liquid mirror telescope is set as if this liquid doesn't make vibrations. And for the second question, for it for the liquid to not spill, there's a sheet which is a very transparent sheet which is applied on the liquid mirror telescope so that it prevents the spilling of the liquid.
Again, this was a very detailed presentation. I liked it. So my question is related to the black hole. What I wanted to ask was that black hole has very different dimensions from all that we understand. And so how do you manage to get reliable information about the study of black hole and related to the death of a star?
Can you repeat the question once again? Want me to answer?
So what I asked was that the black hole has completely different dimensions from our world because it's a completely different plane. It's not the dimensions we understand. So how could you manage to study a black hole and relate it to the death of a star in our dimension?
It's not like just because it's in another dimension doesn't mean you can't study it, right? Like for example, space-time has been calculated with approximations using different equations, right? So you can also say the same thing for black holes. There have been studies related to it, like for example, gamma ray detections from black holes. Although we can't see it, we know it exists because of these different clues. So not direct, we study black holes indirectly, if you got what I meant.
And I would like to add that black hole is actually studied through electromagnetic radiations from the black hole, and as you can see, we capture the images of the black hole because of the event horizon is visible, and from that there's a point of singularity which you might know, which is the point of infinite density where the body has its gravitational collapse. So like all the special relativity by Einstein, Newton, and all of them, the theories have been evolving since then, and there have been several studies of black hole.
Yeah, so my question is about the singularity. What type of singularity do you think a black hole has?
So like, as of now, we know that singularity is a point of infinite density where the body has the gravitational collapse. For the types of singularity, we have not currently studied yet deeply, so we won't be able to answer it.
Okay. And do you think that the singularity of a white hole and a singularity of a black hole are interconnected? Like, I know white hole is hypothetical, but then also, is it possible according to you guys? Yeah. I'm saying that is it possible that the singularity of a black hole leads to a white hole which radiates and emits all the light which is consumed from the black hole?
Okay. But here's the thing, white holes are purely theoretical, right? You can say a black hole is basically a rupture in space and time. So you could say that they are, if they're connected with a wormhole, for example. I mean, they are connected with a wormhole. But I would say somewhat they're connected, even though they exist, but we don't know if white holes exist for now. So that's purely theoretical.
Thank you so much, Singularity Seeker. So we are at the end of our Astronomy 2 project presentations, and we would like to thank our faculty, Mr. Ashwin Shekhar, for their support. Next up, we have the Life Science and Computational Analysis project presentations, where we have the Fly Guys. And in Fly Guys, we have Sia, Bhasin, Sakshi, and Shilpa. And the title of their presentation is, Does Nutrition Impact the Division and Differentiation of Drosophila Gut Stem Cells? So a huge round of applause for them.
I don't know.
Okay,
Yeah.
How do you work it?
This one.
Okay, perfect. That'll be okay.
It's a phone on that.
You know, like, here, this side. Come here, me. You come to this side because you're speaking first. You here, and there you go. Okay. Good morning, everyone. We are Fly Guys from the Life Science and Computation Analysis Science module. I'm Sia.
I am Sakshi. And I'm Shilpa, and I'm going to present about does the nutrition impact the division and differentiation of Drosophila gut. So did you guys ever wonder how we come from a single cell into such a complex human being?
Anyone have any answers?
Okay, so let me answer for you. We come from a stem cells. Stem cells are kind of mastermind cell. They are the special kind of cells that are capable of dividing and then differentiating into to form any kind of cells. So we are basically going to look at the stem cells in the Drosophila gut. Drosophila gut has three kinds of cells. Intestinal stem cells. These are the stem cells that are going to differentiate to form endoblast, and then endoblast will develop into endocytes. Okay. So the question may arise why we choose a model system. So suppose we are going to study our human body. So our human body is so complex that we can't directly go and study it. So we will search for a model that will look similar to our body, and then we will look into it, and later on we will apply to same human being. So we choose Drosophila because it's genetically simple and its 70% genes matches to our genes. And then it has simple body plan that's not as complex as our body. Another thing, their lifespan is very short and they reproduce very quickly. So if we want, we can easily culture them in a lab. Okay. So our objective was that we wanted to investigate the response of Drosophila gut to feeding and starvation. So, but before going to our main question, we had a further sub-question that we wanted to know how we can visualize the stem cells, and then we wanted to know how does the overall morphology of Drosophila gut change in response to feeding and starvation. So, to visualize the stem cells, we used fluorescence microscopy and fluorescence protein. So to begin with our experiment, we had to form null hypothesis that the GFP do not express at 18 degrees Celsius, not even at 29 degrees Celsius. And our alternate hypothesis was that GFP expresses induced at 29 degrees Celsius, not at 18 degrees Celsius. So we are planning a way that null hypothesis has to be proved wrong, and alternate hypothesis, we need to prove it correct. Okay. So our experiment setup, in our experimental setup, we divided the flies under the two groups. One was kept in 18 degrees Celsius and another at 29 degrees Celsius. They were kept in the incubator for 24 hours. And after the completion of 24 hours, we observed them under the fluorescence microscope. So in fluorescence microscopy, we use fluorescence protein. Fluorescence protein has a special characteristic to absorb the light of certain wavelength, and after absorption, it emits the lights that is higher than the absorbed ones. So this enables us to see any single organelle very specifically. Okay. So in case of JP that we have used in the Drosophila, JP absorbs the blue lights and then it emits in the green color. Okay. And to further discuss our observations, Sakshi is here.
So these are the pictures of the gut of the Drosophila at 18 and 29 degrees Celsius under the microscope. So in this picture, in green field, we can see that there is some green dots, which are the GFP cells. From this, we conclude that the GFP cells express themselves at 29 degrees Celsius, not at 18 degrees Celsius. But it doesn't mean that other gut doesn't have the stem cells. They have, but they are not express themselves. So this is our second experiment. So before doing the experiment, we made some hypothesis. So our null hypothesis was that the length and the diameter of the gut doesn't change, and the number of stem cells and over number of cells was also not changed. And our alternative hypothesis for starved one was that all the parameter was smaller than the control group, and our alternate hypothesis for starved fed one was that all the parameter was more than the control group. So to check our hypothesis, we design an experiment. For experiment, we take some flies who were 5 days old, and we divided into it 3 groups: starved, fed, starved. In starved group, flies were deprived of food for 5 days and then fed for, flies were fed normally for 5 days and then starved fed. Flies were deprived of food for 4 days and then fed for the next 24 hours, and then we dissect flies' gut under the microscope.
Oh, it's fine, you play the video.
Okay. So. So this is the video of dissecting flies. So confocal microscope. A confocal microscope is utilize a pinhole to block out of focus light, and this is help us to slice the tissues layer by layer from light and create a 3D image.
Hi, so now I'm going to explain what we observed once we graphed out our data. So in the gut length, in the female and the male experimental groups, we did not notice anything for the male groups, but in the female groups, we noticed that there was no overlap in the box and whisker plots for the starved and the starved-fed group, while there was an overlap in the fed group with the other groups. And in the rest of our parameters as well, that is the diameters, the total number of cells, and the percentage of stem cells, we noticed that there was an overlap between all the box and whisker plots. Now, what does this mean? This basically means that we couldn't conclude that there was a difference in most of the parameters that we observed, while there was a difference in the starved and the starved-fed group that we observed in the female gut length, where we noticed that the gut length of the starved group was significantly lesser than the gut length of the starved-fed group. And we did not observe any difference in the data observed between the different sexes as well. For further questions, we would first like to repeat this experiment with a larger sample size, because we felt we could have obtained a bigger difference in the parameters if we had a larger sample size to work with, because while we were dissecting, since most of us were dissecting flies for the first time, we had a lot of damaged flies. Along with that, we also had trouble using the application Fiji, which we used to count the length and the diameter of the gut. And we would also like to perform this experiment to understand why there might be a difference between the male and female flies when they undergo this experiment, because our instructor Joseph told us that ideally when this experiment is performed, we notice that there is no variation in the male flies, but there is a variation in the female flies. So we would like to explore why. And we also wanted to model the Drosophila gut computationally to look at how the different division patterns, that is parallel and perpendicular, affect the length of the gut. And we did end up doing that in the second week, and the second group, Drosodudes, would be presenting that. That's all from us. Thank you so much for listening, and the floor is now open for questions.
Thank you, Fly Guys. We'll take some questions. You've asked.
I had a question. If you guys could only observe the GFP cells under the green light, then why did you also do that under the red and the bright field? Sorry, not light field.
So I can answer.
So we just look at, we wanted to confirm that it's only showing in the green light. So in the red light, we didn't saw anything. So we get sure that it's only expressing in the green light. Okay.
So in the second experiment, why were the flies kept at 29 degrees Celsius for just one day?
That is such a good question. So the thing is, if we kept it there for longer than a day, all the stem cells would have regenerated the entire gut. So if you looked at it under green field, it would basically be just full of bright green lights. So yeah, that's why we just need to keep them there for like a day, because otherwise the entire gut would be full of stem cells. Thank you. Oh, we can't hear you, sorry.
No.
I can run. Oh. We can all just club together. Karaoke.
Okay. Is this better?
Yeah.
Okay, so when you observe differences between different groups, at what point do you decide those differences are significant? Like, was there a boundary you established?
That is a good point. Can we go back? Okay, so do you want me to explain the whole statistics to you? Because I would love to. Okay, so imagine these graphs, since they are overlapping, as normal curves, right? So if they were to be normal curves, we notice because of the overlap, there could be a suggestion that they fall into the same confidence interval, meaning they have the same true mean value, which would mean that there is no difference between them, since they're in the same confidence interval, have the same value. But then here, and we are doing this with a 95% confidence interval for your information, since there is a difference in all of the values that we calculated for the starved group and the starved-fed group, we cannot confidently say that they fall into the same confidence interval, thus meaning that the difference is also significantly lesser. Or different, my bad. I love that question. Thank you for asking. Oh. I'm so scared. Okay.
Yeah, so I liked your presentation. What I wanted to ask was, you kept the gut at different temperatures, and every organism adjusts its cells to a given temperature based on the skin and the outer surface. So how did it not change at any temperature, like from its original shape?
I'm sorry. Yeah, could you repeat your question?
In the table you had shown that the cells did not change their shape at 29 degrees Celsius from its original shape. So every cell adjusts its shape according to the temperature and is constantly changing. So how did it not change its shape?
Oh no, that was not a conclusion, and that wasn't really related to our experiment either. So the flies we were using, they were genetically engineered to express the GFP cells only at 29 degrees Celsius, and that's what we were trying to do with that experiment. It was basically a confirmatory experiment, nothing to discover something new. We just wanted to confirm that the flies are working as they're supposed to, and that we can see the stem cells only at 29 degrees Celsius.
Yes, and my second question was that you had done an experiment on a fly by starving it for 4 days and feeding it for 1 day, while the rest was only starving and or only feeding. So why did you do the mixed experiment?
Well, we wanted to see how the we wanted to see how the fly guts or how the fly's gut would respond when it was given food after being put in such an extreme condition, right? Because it was probably hungry. So we wanted to see how it would use this energy that now it's getting to use its stem cells to its optimal benefit.
Okay, thank you.
Thank you so much.
Right, we are at the end of our time.
Oh,
thank you so
sorry.
much, Fly Guys.
Thank you.
Next up, we have Droso Dudes, where we have Mehek and Masoom. And the title of their presentation is Agent-Based Model of a Drosophila Gut Stem Cells. Can we have a huge round of applause?
Good morning, everyone. Sorry, it's good afternoon. So I am Masoom, she is my friend Mehek, and one more member of our team, Hinal, is not here due to some reason. So we are here to brief you all about agent-based modeling of biological system stem cells. So, we are junior learning partners and they are senior learning partners. Together we are Droso Dudes. Next slide. So, what is agent-based modeling? Agent-based modeling is a technique to model the behavior and interaction of individual agents in order to understand how they create bigger patterns at the system level. Agents do interactions to form system, and we are doing this on software called NetLogo.
So this is the first example, that is, you all know about the tragedy happened in Canada, fire tragedy. So here agents are the trees and the system is forest.
This is the second model, ant behavior. The agents are ants and food. The system is ant colony.
This is the third example that we did in the NetLogo model. So this model is designed by the Sugat and Joseph, and we will talk all about it. So here agents are the stem cells and the system is Drosophila's gut.
So now let's deeply dive into stem cells in the gut of Drosophila.
So first, our research question. Our research question is how the length of the gut is affected by the pattern of the number of cells divided. So you all know there are two parameters. First, parallel parameter, second, perpendicular. So parallel cell division and perpendicular cell division. You all know all about parallel and perpendicular, so there is no need to talk more.
Based on a hypothesis, based on a research question, we made our hypothesis. So our null hypothesis is pattern of division has no effect on the change in length of gut. And our alternate hypothesis is pattern of division has impact on change in the length of gut. So perpendicular pattern of division increases the length more as compared to the parallel one. So, while doing the experiment, we had our fixed parameters and experimental parameters. So, our fixed parameters are initial stem cell was 10, stopping point was 20, permitted distance was 1.01. Permitted distance means the distance between the two cells. Probability of division was 1. Fixed new cells was off. And our experimental parameters were random, parallel, and perpendicular.
So this is our data. This is our bar chart collected by the data. Here, this is the random control. It means parallel division of the cell and perpendicular division of the cell are both on the off stage. Parallel division is the cell, it means only the parallel division is on, and perpendicular, only perpendicular is on. And the ticks here is the individual trials that we make in the data. So about the conclusion, Mazam will tell you.
So after doing the experiment, we got the result that after studying each trials separately, we noticed that there are some changes, like some values are higher, others are low. At this point, we are unable to accept or reject our null hypothesis due to large variations and insufficient data.
So our limitations is really we did only one, so sorry. We did only one trial in the permitted distance, so we should take more trials in the permitted distance. Basically, this is the basic limitations. And our future question is, prior researches has shown that muscles layer restricts the enlargement of the gut. So by using this knowledge, we can model a model layer computationally and study how it's affect the length of the gut through parallel and perpendicular division. So thank you. Any questions?
Hello. So I understood a lot of your presentation, but one thing I did not understand is what you meant by division. How do you define division, and what were the pictures you showed in which there were some highlighted cells?
Which picture? This? So can you repeat your question?
How do you define division? So you said there are parallel and you said something about there being parallel divisions, perpendicular divisions. So how is that here in these pictures, and what do you mean by a division?
No, it means how the cell can divide. Cell divide parallelly or perpendicularly. Parallelly, it means cell divide from left to right. So assume this is the gut and it is in this phase only. Okay. So parallelly, it means cell divides from left to right, from here to here. And perpendicularly cell divide from up to down or down to up. Yeah, but it is the modeling. So in model we have no, if we put it random, then it divide both parallel and perpendicular.
No, my question was that how do you say something is parallel? Because if you change the frame of reference, parallel might become perpendicular and vice versa.
No, we can see it in model and as.
Thank you, Masoom. Thank you, Mehak. We have, for life sciences and computational analysis, we have a last group, and who are called neuro leaders, where we have Sheetal, Meenal, and Shravani, and the title of their presentation is Agent-Based Model of a Neuron. A round of applause for them, guys.
Can take that mic. नहीं कॉल में दो ही है yes.
So, hi, we are Neuro Leaders and myself Sheetal, and I'm with my group mates Meenal and Shravani, and we will be talking about the neuronal biology. So basically what we are going to talk about, like what is a neuron and the basic functions of neurons and the models of neuron and future direction and conclusions. So today we are computationally modeling neuronal activity. So here it goes like, what is a neuron? The basic definition of a neuron is neurons are the building blocks of a nervous system and crucial for the communication, control and cognition and the sensation part. So why neuron? So basically it enables the communication between different parts of the body and the brain, and the brain's ability to recognize itself by forming new neural connections throughout the life. And it also regulates the vital functions like heart rate, digestion, respiration, and etc. And also, if we are studying about the neurons, it will help us about the study of brain functions and the development of treatments for neurological disorders. So, where is the neuron found and what we are looking for? Basically, the neuron is found all over the body, but basically what we are looking for is the part of a neuron. We will be talking about the different concentration of ions between outside and the inside of the membrane. And for this diagram, we will be talking about later. So how the mechanism of how signals are collected. So basically we have some inputs, then it will move, it will be collected by the dendrites, and then it will move towards the brain or the spinal cord. Then we will be getting the outputs. So now I have an example, like if we have mango, sugar and the milk, it will be processed and then output will be the mango juice. So like this, we have smelled some, we have detected a smell. It will be processed by the brain. The output will be the food which you have smelled or something else which you have smelled.
So why is modeling biological system in computational analysis important? This is because it helps us make predictions and helps us test our hypothesis. It also helps us save our time and also helps us, it helps us conduct our experiments which are not expensive and helps us time consume. Also helps us understand our knowledge by using computers. Next slide. So to understand our biological systems more precisely, we made 3 models. First one was for diffusion, second for drift in an electric field, and third one was for biological realistic concentrations. So this is diffusion. To learn the concept of diffusion, we first understand that what is diffusion through this model. So diffusion is the net movement of molecules from the area of high concentrated area to an area of low concentrated area. So here, take it back another. Okay. So here you can see that the molecules are concentrated at one area and they're spreading across to a lower concentration area. So this is the second model that we built. Here we were understanding about the drift in electric field. So these molecules are in an electric field and you can observe that the yellow and red ones are not polar. Due to this, they are not moving towards this membrane, which is charged, and the green one, you can observe the green one are mostly closer to the membrane. This means that they are charged and they're getting attracted to the membrane. So let's connect all these models into the biology of the system. So here we can see that now over here, this is the system, and how we connect this to the neurons is, this is, okay, wait. So this part, this is the neuron, and this one, this is the cell membrane, and this one is the surrounding. So from a neuron, the ions are passing outside into the surroundings by the help of the channels. These are the channels, whereas in the previous slides, you saw that there were no channels and ions were getting bounced and coming inside again into the cell. But whereas over here, there are channels which are ion specific. Channels are just proteins that are on the cell membrane and which helps ions to move from an cell to outside. And they behave as open doors.
Okay, so a spike has two components. So first is the Na plus and K plus. So we all know that a neuron tries to maintain its stability. So the initial part of the strike is a straight line, and then as we are modeling it is, so first we open the Na channel and the Na plus ions flow in, and then we open the K plus ions and they go outside. So first there is an increase in the in the spike, and then there is a decrease. So this picture is a zoomed image of the movement of the ions, because each channel only allows specific particles to move across it. Okay, so we made this biologically realistic model based on the concentration. So the red particles are the Na plus ions, K plus are the yellow ones, and Cl minus is the green ones. So this is the neuron, and this is the environment in it. This is the cell membrane. We can observe a few channels in it. So we'll see the working of the model in the next slide. Okay, so here we have built a model of movement of the ions. So we can see a few sliders named as number of channels and its chances to go in another side. So we can see a graph which indicates the rise and fall of the membrane potential. We could also observe the net positive charge inside, which is basically Na plus K minus Cl. So first we opened the Na channel, and we could observe that all the Na moved inside, due to which the net positive became high and the graph was increasing. And when we opened the K channel and closed the Na1, so we could observe that the graph was falling down. So this was the whole representation of the moving of ions from one channel to another.
So, so what we have modeled in this model, basically this gray portion indicates the neuron, and the portion which includes the yellow ions, this is the inside portion of the membrane, and the blue line is the membrane, and the outside environment are the red and the green channels. So our future question is, basically currently we are manually opening and closing our ion channels, but for future we would like to model biologically realistic channels when the channels open and close on their own. Like for example, like this membrane has encountered a sodium ion, then it will basically open automatically if membrane has encountered any ion. So this is our whole life science team. So my heartfelt thanks goes to our professor Sugar, Joseph and Mehrab, who helped us throughout the 1 month with their tireless efforts. And also my warm thanks goes to our TAs who were always there for us in any way and any time. So thank you.
Thank you, neuro leaders.
Okay. So why do we need channel proteins for the ions to pass? Why can't they pass through cell membrane directly as water? And different molecules can pass through the cell membrane.
Because channels are provided, there are proteins which are helping the ions, because ions are polar, and if you see the cell membrane, it is composed of phospholipid bilayer, and it has fatty acids which are non-polar. So ions can't pass from a non-polar region, and due to which the channels are needed for them to pass.
My question was that in the model that you showed, if the ions were of the same charge as the channel, then why didn't they go opposite side? Like, they didn't get attracted, sure, but they did not repel either.
Can you please repeat it?
Like you said that
be louder.
The membrane was charged. You said that the membrane was charged, and then the negatively charged ions got attracted, but the like the positively charged ones didn't repel either. So how did that happen in the model?
Slide.
Do you want to?
आगे आगे ट्रांसपोर्टेशन ऑफ आइडिया वाला निकाल पीछे जा रही है तो अरे यही है ये वाला हाँ this one. So here we can see that here is the cell membrane and here is the positive, so this is the negative part of the channel and this is the positive part. So we know that sodium one are positive ones, so they will get attracted towards the negative one and Cl will go out. So yes, attraction and repelling of ions based on their charges basically.
He's still not. Was he asking? Is that question?
Hello, great presentation. So I have two questions. First one, we've learned in school that the diffusion is in Newton meter per second. And you said that the definition of diffusion is the amount of movement of the molecules, which would just be in meters. So is there a more refined definition, a more formal one? And the second one, you can answer after this. What are the parameters for a model to be biologically realistic?
Okay, so you need the definition for the diffusion, right? So diffusion is basically the net movement of molecules from a region of highly concentrated area of those molecules to a lower concentrated area, and this is naturally happening with ions in your body.
But then how do you measure it in Newton meter per second?
It's a great question, but I will get back to you. I don't know.
Thank you. And the second one? What are the parameters for a model to be biologically realistic?
The concentration of the molecules.
Basically what we need for biologically, if these channels would not be affected by the diffusion rate or the transportation rate, we could include the membrane permeability, like it could, if what I said, this future question, it will include that, the membrane has encountered the sodium channel or the ion, it will definitely allow the sodium ion to move.
So I wanted to say this was a very unique presentation and it has great potential. So what I wanted to ask was that you had represented the movement of the particles in the form of a kind of wave, right? So I was wondering that these particles are moving in channels, so they have high concentration, low concentration. So wherever there is low concentration, the particles of any of the given elements, sodium, potassium or chlorine, can move from high concentration to low concentration. So it will move from different channels, oscillate between different channels. So it will move in all four directions. So why can't you represent the movement in the Cartesian plane as 0, +1, -1, 0, +1, -1?
Can you please elaborate the question more so that I can understand and answer you accordingly?
No, what I had a doubt in was that these particles move from region of high concentration to low concentration.
Yes.
So it can change the channels they are in. So it can not only move back, forward and backward, back and forth, but left and right as well. So why can't it be represented in a Cartesian plane?
Like our motive is to see like the cells are diffusing from one side to another. Our motive is to see like which ion is moving from a specific ion to the another side. So what we want to see, like, okay, this ion has moved from one place to another. At what rate? Okay, this side was the higher concentration place, and this is the lower. So we want to see the movement from which it has moved from higher concentration to low or low to high.
Okay, thank you.
All right, thank you guys. So at the end of our life science and computational analysis project presentation, we would also like to thank our professors, Mehrab, Sugat, and Joseph. Can we have a round of applause for them as well? All right, so we move to the last section for today's presentation, which is QBio and computation analysis. And we have our first presentation, who are called the Sonic the Hedgehogs, where we have Anvi and Mija. And the title of their presentation is very interesting, and it's called Sonic Analysis of Vowels, Not as Easy as A-E-I-O-U. So a round of applause for them.
Because we did it on PowerPoint first. It's not compatible with Why is it not working? The image is not loading. 1 second. There's an image here. No, actually there's an image over here. I don't know why that's not loading. Is it possible to do it on my laptop? It's already open here. Or if it's not, then it's
On Google Slides also it's not visible?
No, it is actually visible on my laptop. I don't know why it's not working. Maybe can you enable editing? Maybe then it will show. Enable editing over there. Why is it not showing the image?
Can we do it without that?
It's fine, it's fine.
Yeah?
Not that bad.
Good afternoon, distinguished dignitaries, gracious guests, friends, Romans, countrymen. So, we are here today to present to you our project, Sonic Analysis of Vowels, Not as Easy as A-E-I-O-U. So, first off, what is a vowel? Any brave souls want to answer that question? Thank you for taking the cue from our presentation title, but it's not as easy as that. So a vowel is a sound that is produced without constraint or restriction in the vocal tract. So there is no buildup of air pressure. So there is no buildup of air pressure in the vocal tract. What does that even mean? So basically, a vowel is a sound you can scream for an extended period of time. I suggest you try this experiment only after we finished our presentation. So one thing we have to explain to you is that vowels have 3 parameters: height, roundness, and backness. So when pronouncing the vowel, height is the distance of the tongue from the roof of the mouth. Backness is the distance of the tongue from the back of the mouth. And roundness is whether the lips are rounded or not when pronouncing the vowel. So let's look at a real-life example of this. So this fella here is Daniel Jones. He is a renowned biologist and phoneticist, and he made our life a lot easier by taking X-ray photos of his jaw while pronouncing different vowels. So here you can observe the effects of height, roundness, and backness.
Now, since we've covered the introduction, let's move on to the objectives of our and goals of our project.
So we aim to perform an analysis of languages based on sonic differences rather than historical analysis, to obtain an understanding of physiological aspects of sound production based on the positioning of vowels in the vocal tract, to appreciate the sonic similarity and dissimilarities between languages, to further analyze which languages would be the easiest for language learner to understand based on their native languages, and to understand how certain languages would be advantageous to those with dysfunction in certain areas of the vocal tract by analyzing vowel charts. Now, if you've ever woken up and thought to yourself, man, I wish there was a way to analyze and chart the vowels I'm going to speak today in a systematic arrangement. If you're thinking that, please get a life. But also, vowel chart. What is a vowel chart basically? To put it in simple words, it is a systematic arrangement of the vowel sounds in a certain way. It represents the position of the tongue in relation to the openness of the mouth when you're speaking the vowel. This is what a vowel chart looks like. So as you can see, the vertical position of the vertical position of the chart represents how open or closed your mouth is while speaking the vowel. And a vocal tract has three parts: front, center, and back. Now, a vocal chart can be a trapezium or a triangle based on the languages. Why? Why do you ask? It's because trapezium and triangles are the only shape that are closest to the shape the vocal tract is. These are sample vowel charts. This is an English vowel chart, and this is a Hindi vowel chart. As you can see how different the position of the English chart and Hindi chart are. This gives us a good point. Vowels are the defining differences between languages. They are the ones which make the accents different, and to put it in simple words, they are the ones which make the sound of the language different.
So, have you ever tried learning a language but had to stop because the language was too difficult to pronounce? Okay, y'all are smart, but yes. So we might have an explanation for that. So vowels are the trickiest part of a language to learn. So consonants can be learned easily, but vowels are what solidify the differences between languages. They're like the main determinants of accents. So perhaps the language you picked had vowels very different from the vowels in your native language. So, to analyze the differences between vowels of different languages, we have taken 12 languages. So, we have taken the coordinates of the vowels of 12 languages using a module in Python, which is known as Pygame. Then, further on, we plotted them using matplotlib and superimposed them over each other using pyplot. So the points of different colors represent vowels of different languages. So furthermore, we've analyzed the distances between the vowels in different languages to get the relationship between them. So this is a network graph, which is a visual representation of an analysis. So in this network graph, the points represent different languages, and the lines between them represent connections between the languages. The thicker the line, the stronger the relationship or connection between the languages sounds. So, to make this more usable for people, what we have tried to do is create a user interface where a person can input their native language, and then, depending on their native language, we will output a list of languages that are sonically similar to their native language and will be easiest for them to learn.
So based on that, we have given a recommended list of languages which are sonically most similar to in your native language. Now, what if a person has, suppose, a speech defect? Interesting part about speech defects is that they affect either the front, central, or back of the vocal tract. Let's suppose somebody has a stutter. Stutters usually affect the center part of your vocal tract. Lisp. Most lisps affect the front part of the vocal tract. So using this graph that we have implemented, you can see how different languages are concentrated at different parts of the vocal tract. And we have used that data to create this technology where the person can enter what part of the vocal tract is damaged, and based on that, we will give the languages which are least concentrated at that part and most concentrated at the parts which are not damaged. So suppose here the person has clicked central, then these are the recommended languages like Malay, Thai, Hebrew, Mexican, Spanish, which are least concentrated at the central and most concentrated at the front or back. This is a great technology which can be used for speech, people with speech defects, as it will be most effective for them to learn also, and also for the speaker to clearly hear them also. Now, why did we do this project? Let's look at the major implications.
So first off, this project can act as an aid to language learners and can be implemented in language learning apps to decide what language you want to learn based on the sonic similarity. So the more sonically similar, as I said, the more easy it will be for you to learn. And learning is more fun when it's easy.
And another great tool which has not been used in language learning apps now are the language and other speech defect technology. Since people with speech defect deserve to feel more included, language apps can implement this technology where they can ask the person what part of the vocal tract is damaged, and based on that, they can give a recommended list of languages what would be easiest for the person to learn and for the listener to hear also.
So our project tries to analyze languages based on their sound, sonically, rather than their history. For example, French and Spanish are descended from Latin historically. However, though the grammar, etc. are similar, sonically, French and Spanish sound very different from each other and may be difficult to pronounce.
And if given the chance to develop more, this project can also be implemented with the speech recognition technology, where the person with the speech defect can talk to the computer itself, and the computer can analyze what they're trying to say. And this can be used in general hospitals, schools, daycare, and even everyday to life. Language is a big part of our lives, and sometimes we even fail to acknowledge it. So we hope you enjoyed this presentation, and I know all of you are hungry, so we wish we could satisfy your hunger for knowledge instead of your actual appetite. And at the end, we would like to thank our professor, Dr. Shadipta Tung, and our DS for the endless guidance. Thank you so much.
Questions?
So it was really commendable what you guys did. I think it was really interesting. I just have one question. What was your inspiration that got you to come up with this idea?
Okay, so my partner here, Miha, she was reading a book called The Art of Language Invention by David J. Peterson. He is actually the writer for the fictional, he actually came up with the fictional languages in Game of Thrones. And so basically, we were fascinated by his sort of biological and sonic and physiological breakdown of vowels rather than a historical one, and languages. And like she mentioned, any language families you will find on the internet, like French, Spanish, Italian, they're grouped historically, like all of them are derived from Latin, but do French and Spanish sound any similar? So we are fascinated by that, and we hope to implement that in our project.
Oh, that's great. Nice.
Hi, I loved your presentation. So I basically had two questions regarding this. My first question is that your project is basically revolving around vowels, right? So why not consider the consonants and just the vowels?
So as I said, consonants are somewhat easier to learn than vowels. Though they are different from language to language, they are easier to pick up, and vowels are the main determinants of accents and are basically the essence of the language that way.
All right, and my second question is that you guys said that the user can enter their native language and the program will give out the sonically similar languages provided. So there are almost more than 7,000 languages worldwide, right? So how much variety is your program actually offering when you say native languages?
So for now, for like a much more local thing, we have done only 12 languages, but obviously the data can increase to up to 5,000, 6,000, and even all the languages included. That would be too difficult to do, but yeah, it can include up to thousands of languages, but for now we have kept the data small. We can't possibly do 1,000 languages in a week.
Yeah, thank you.
Hello. So I would just like to say the presentation was very informative, and that's also a new perspective on language that I did not expect. But my question was, when people are selecting a language to learn, they have reasons behind it. Like, let's say I want to go to Germany or I want to read German literature, then that's why I select that language, and that's what keeps me learning it. So this program that you're suggesting would just suggest a language that would be easier for me to learn. So what incentive would I have to actually learn that language?
So yeah, it's just a recommendation. It doesn't have to be what you have to learn. It would be a bit easier for you to speak, but obviously, as you said, and I agree, people have different motivation from learning a language and stuff.
And maybe if you can look at from a better perspective also, suppose you're learning Italian because you want to go to Italy, and suppose your native language is Hindi, you can see how different or similar Hindi is to Italian, and you can see what challenges you're going to face when you're learning Italian.
So this presentation has a lot of great potential in the future as well. So I have two questions. One question was that won't the pronunciation of the vowels change when the accent changes, thus causing the person to have a different perspective on which language to learn, the software I mean?
I didn't understand the question. Could you repeat?
No, like whenever each person speaks the language differently, so if you have a different accent or a different note, then won't the pronunciation of the vowels change?
So accents are primarily determined by your native language or what language you speak at home. So our program is based on native language, but if like a non-native speaker or a speaker comes from a different place, will come from it, often will be changed.
So you're saying like there could be two different accents for Hindi and
Yes.
what you're trying to say. Okay.
No. There could be two different accents for speaking Hindi itself.
No, that's what I'm, yeah. Okay, that's a very interesting point. We hadn't thought of that. He's saying that there could be two different accents for Hindi. So how will you, and if the vowels differ in that also. Okay, wow, it's a really good question. That's a thinker. One second. Maybe even though the accents are different, the vowels, the essential vowels, they remain the same. And obviously, this data is does not have a lot of data points to get from. But if implemented, yeah, we could actually implement different accents for Hindi and different accents for other languages also. That's what, and we were actually planning to take the example of Spanish, like Mexican Spanish and Colombian Spanish. All of them are different. So that is just increasing the data points and then adding more conditions to your code. That's not going to be too hard, but that can actually be implemented. That's a very good point. Thank you so much for that.
Yeah, and the second is, would you like to do some collaborations with software companies to turn this into a language learning app or something?
Sure, yeah, if we can develop it more, like she said there were 7,000 plus languages, if we can at least get it up to maybe 2,000, 3,000, yeah, I mean, why would software companies want to take this offer? And we would also like to partner with them. Thank you for that. Thank you.
My question was similar to his. My question was that how are you able to draw a definitive vowel chart without referring to a specific region? Because as you said, the data set, I'm not sure how many data points it has. Yeah. So you, I think, will have to refer to a specific region to say that this vowel is pronounced here in the data chart.
Yes, so my answer is also going to be similar to that. We have only taken like a broader perspective of Hindi now, like Hindi-speaking states, like that kind of accent. But yeah, if you can just add more, I can add more data points of different accents of Hindi and then change on how the user can select different options and then get their language recommendation based on the accent and the native language. Would you like to add anything?
No, just the more data we collect, the more accurate the model will be.
So it is just a matter of collecting more data and then increasing our database.
All right. Thank you so much, Anvi. Thank you, Meja. Next up, we have some Potterheads, and the group is called Ravenclaw, where we have Isha and Haley. And the title of their presentation is Neurodynamics, the Speed of Thought. A round of applause, please.
afternoon, everyone. Hello. Yeah. Good afternoon, everyone, and thank you all so much for your time. Today, I, Isha,
and I, Haley,
present to you Neurodynamics, the speed of thought. So before we begin with understanding everything, let's do a quick understanding of what actually our project is. Today, we are here to learn how to simulate the effect of various substances on how fast or slow the speed of a neural signal is.
So let us start with what a nervous system is. It is a network of nerves that transmit signals between different parts of the body. It helps in movement, and it also coordinates different parts of the body, and it also maintains homeostasis. Now, the nervous system consists of two parts, the central nervous system and the peripheral nervous system. The central nervous system consists of the brain and the spinal cord, and the peripheral nervous system consists of all the nerves that emerge from the brain and the spinal cord and go throughout the whole body. The smallest part of the nervous system is a neuron. So let's see how a neuron is.
So the structure you see over here is a structure of a motor neuron, and it consists of four main parts: the cell body or the soma, the dendrites, axon, and myelin sheath. So the thing you see over here is called the cell body or soma. It contains of the nucleus and is crucial for processing information within the motor neuron. These branched extensions are called dendrites. They receive the signal from other neurons. Over here, this long projection from the cell body is called the axon, and it is the most important part of the motor neuron because it is used for transmitting the electrical signals. Lastly, over here, the axon also transmits the signal out of the neuron into the other muscle receptors or another neuron. The axon is covered with these translucent bubbles you see over here called the myelin sheath. It's basically a fatty acid that insulates the axon and increases the speed of the impulse. So let's take a quick look at the pathway of a brain signal. The brain signal starts at the motor cortex in the brain, which is where all movement is planned and initiated. From there, it moves on to the second part of the central nervous system, which is the spinal cord. After it passes through the upper spinal cord and then the lower spinal cord, it will shift into the peripheral nervous system and go to the muscle receptors. Over here, for our project, we're going to be using our hand as the muscle. And I know because you're all really hungry, we're going to be eating an apple today. So once the muscle receptors in the hand receive a signal, they will move or contract based on whatever the impulse requires it to do so.
So now let us move on to our project. For our project, we've taken three substances into account: caffeine, alcohol, and adrenaline. Caffeine usually makes you awake. So there's this chemical in our brain known as adenosine, which will make you feel sleepy. But caffeine blocks this chemical and it makes you more awake. It also stimulates the release of another chemical that is known as dopamine. That is why you usually feel more active when you have caffeine. The second substance we've taken here is alcohol. It usually slows down the rate of the impulse. When you have alcohol, it's usually you forget things easily, or you become happy or sad for no reason. This is all because alcohol affects the cerebellum part of the brain. And the third substance, unlike the first two, is adrenaline, which is a hormone that is present inside our body. It is in the adrenal gland that is present above the kidneys, and it is released only during the fight and flight situation, and it also increases the rate of impulse.
So before we understand how the code actually works, we need to take a better look at how we've integrated the three substances that Haley mentioned into our code. There's a few assumptions we had to make because we're simulating a real-life process. Firstly, in real life, the speed of a neuron signal varies from 3 to 120 meters per second. But for our project, we've taken the assumption of 50 meters per second. Secondly, we're assuming that at the beginning of the simulation, the user has 0.0 milligrams of caffeine, 0.0% of blood alcohol content, and 10 nanograms per liter of adrenaline. And lastly, because the user is allowed to change the levels of the substance as to how they want, we also need to understand how a change in the level of substance affects the speed. So say you have 100 grams of caffeine in your body, it is going to multiply the original speed by 5. Secondly, if you have, say, 0.02% of alcohol in your blood, it is going to decrease the speed by 2. And lastly, increasing adrenaline by 10 nanograms per liter will increase the speed by 7. Now, all this data has been collected through a lot of research and understanding that we'll show you the papers that we used later. So what our code does is basically it's a simulation setup. It simulates a real-life process of the brain signal moving from the brain to the hand. It generates data based on the parameters we feed it, and thus we say it's based on parameterization. In the sense that we don't have a fixed code for it, the user can control the level they want and simulate it accordingly. It also provides a graphical visualization. Once you've run the program, at the end you will see a graph that explains and analyzes what you just simulated. And lastly, which is the most important thing, is that it can be used as an educational tool. It breaks down a very complex concept and makes it something really simple to help people all over the world understand what processes in their body are like. So in the code, we first set up something called a Pygame environment. For those of you who don't know, Pygame is basically a module within Python that allows you to animate objects. Once we've done that, we set up the screen in such that all the images and all the variables are placed, so it's clean and coherent. After that, the user is allowed to adjust the level of any substance however they want. Obviously, the substances are limited to the ones we provide. And after that, the neuron will move based on the speed of determined by the level of each substance. And then, because we want to allow the user to keep using it with different levels of substance, hitting the spacebar allows you to reset the whole program and run it again. And it'll also produce a graph at the end. We've done that using this other module called matplotlib, which generates graphs based on the data you feed it. And lastly, the loop will keep running until the user chooses to quit. So this is just a so this is just a photo of our simulation. This is exactly the pathway of a brain signal that we showed you. It starts from the brain, the spinal cord, and then the hand. So yeah. Over here, the first trial is where there has been no change in substance. Yeah. And that's the neuron signal moving to the brain with the apple. Pressing space resets it. You'll see this the same with 100 grams of caffeine, with 0.02% of alcohol. That's a little bit slow, so another message for all of you, don't drink and drive. And at the end, you'll see an increment of 10 in adrenaline, which will be faster than increasing 100 grams of caffeine. You can also change a lot of substances at once itself. Due to a time constraint, we just showed 3 of them separately. Yeah. And you can go to the next slide. And this is the graph that has been produced. So you can see that adrenaline, just 20 nanograms per liter of adrenaline took the least time, while only 0.02% of alcohol took the most time.
So now let us move on to the implications of our project. First of all, it improves understandings by this model, by the simulation. We can actually understand how each substance affects our brain. For example, caffeine would increase the rate of impulse and alcohol decreases. The second implication is better treatment plans. Doctors and scientists could take this simulation and show it to patients to make them understand what is happening inside their body and what they should take care of. The third is patient education. A lot of the times, patients can't visualize what problem is occurring inside their body. So we can take this simulation and help them understand how each substance affects their body in a different way and what they should do to make healthier choices. This is a very simple code which we've made, but an advanced model of this code could have many scopes in the future. First is exploring more substance effects. Right now, we've only taken 3 substances into account, but later more substances like nicotine or antidepressants, which could also show the different rates of impulses for each of the substances. Long-term effects exploration. Right now, it shows the immediate brain impulse that is sent from the brain to the body part, but later on, we can study about the long-term effects exploration. For example, caffeine causes cognitive defects in our body, and that could be studied in detail. Personalized assessments. We could actually ask the user to input his age, gender, and health problems to make a tailor-made result for each and every person. And the last is public health initiatives. What we've learned from this project, we could actually collaborate with other health campaigns and let people know about how each substance affects their brain, and in later parts, make healthier choices for each and every one of them. So yeah, this was our presentation, and these are the papers that we've used for all the numbers we've already given.
Thank you.
Thank you guys. Do we have any questions?
Okay, so for 2 out of the 3 substances you mentioned, coffee and alcohol, you can increase the content in your body by just ingesting more of them. But how do you modulate the adrenaline content in your body?
So adrenaline always exists in your body at 10 nanograms per liter, and it changes by a 10-fold in a stress. So it's a fight or flight response. So when you're in stressful situations, it increases at a 10-fold, but by exercising, it increases at almost at a 50-fold. So this is how adrenaline changes in your body.
Yeah, so it was also a very nice presentation. I had a doubt regarding the computation. You can actually, I was wondering, use 0101 to represent the electrical charge flow, because when it's flowing through the axon, it's moving, and then there's a gap between 2 axons, so it stops. So it's 10 on, off. So could you represent it like that?
Yeah, so that's exactly what we've done. Instead of 0101, we've made it true or false. So if we've set if conditions, so that when it reaches a point, the movement is either true or false.
Yeah, so wouldn't using 0101 make it very efficient for computers to process as well?
Yeah, we've done Python for coding.
Okay, and the second question I had was, you mentioned adenosine. Adenosine, I remember, made us quite dull. Yeah, so adenosine made us quite dull. So, but I recall learning in my textbook, adenosine triphosphate creates energy. So I was wondering that when does the tipping point come where adenosine reacts with 3 molecules of phosphorus to become adenosine triphosphate?
Acceptors of adenosine. That's all. There is no formation of ATP right now. That is a whole other process. It comes under another category.
Okay, thank you.
So first of all, I really loved your project. It's a really cool idea. So my question was, how did you guys even think of this? What was your inspiration for this project?
So we didn't really have an inspiration as such. We both like biology, and we were interested about learning more about the nervous system. So we searched, and we got to know that we can actually change the, do something about the impulse, rate of impulse. And so we were good. We were really excited, so we just did it. No such inspiration.
Can I ask a question? Excellent presentation, guys, as always. And what other substances can you use other than caffeine, alcohol, and adrenaline to show the simulation of whatever you did?
Is your question what other substances we can use?
Yes.
Yeah, so we can use nicotine, antidepressants that are already present in the body, or maybe substances that we consume sometimes, like tobacco and stuff.
So for example, nicotine, what effect would it have on this whole process?
It would decrease the rate of impulse in our body.
Okay, thank you so much.
All right, thank you. Thank you so much, Isha. Thank you so much, Haley. Can we have a round of applause for them? So this was Ravenclaw. Now we have Gryffindor, and where we have
Sheshadri and Shivangi, and the title of their presentation is Nutrition Analyzer. A round of applause for Shivangi and Sheshadri.
Greetings of the day, everyone. I, Shivangi,
And I, Sheshadri,
are here with our project, Nutrition Analyzer. With the name, you must have guessed that this is something about analyzing the nutrition. So yes, you're right. This project is here to help people track their dietary intake and exercise routines for better health management. But the question arises, why this project and how will it be helpful for all of us? So yes, there are many apps and websites which do the same thing, but none of them cater to Indian audience. But this does. Yes, this project contains almost 60 food items which belong to the Indian cuisine. All you have to do is just choose your food item and enter the quantity in grams. Then it also takes care of fitness. There are almost 12 exercise options. You can choose from them. You can specify the duration, and then take every supporting health objectives.
Okay, so before going into further details, let us understand what are nutrients. Nutrients are organic substances which are required for regulating body functions. Okay, so now the question arises, why balanced nutrition is important? First, it is crucial for overall health and well-being. Second, it is necessary for bodily functions. And third, it supports optimal growth, development, it strengthens the immune system, and it gives us the energy to work. Last but not the least, it reduces the risk of chronic diseases such as obesity, diabetes, etc. Okay, so the points that we have discussed just now, how to keep check on them. We can do that with the help of our project. All you have to do is you have to input the data, you have to select all the meals that you have had in a day, and you have to fill in the amount, you have to enter the amount in grams. We have already made dictionaries in our code which have all the food items along with their respective nutrients that they contain per 100 gram. So what our program will do, it will calculate the total nutrition that we have consumed in a day. After that, we also have options for workout routine. There are 12 of them. You can select any of them. And you can also, if you haven't done anything, you haven't worked out, or you haven't done any exercise, you can select none. And also, you have to specify the duration. After that, the program, it will give the output, like the excess calories. It will reduce the calories and macronutrients that you have burned in the exercise from the total consumed nutrients. After that, you can also store your day-wise data in a file. We have already specified the file paths in our code. After that, after doing this for the past 7 days, you can generate weekly graph. Okay, so now let us understand what are the tools, what are the important tools that we have used in making this program. So the first one is EasyGui. It is a Python library that is used for creating graphical user interfaces. We have all the message boxes, choice boxes that you'll see when we run the code. It is possible due to this library. After that, we have used Matplotlib for creating the graphs. Then we have used dictionaries and lists for storing all the values. Dictionaries we have used for storing the food items and exercises. Lists we have used for storing the days of the week and meal of the day. Then we have used loop and conditional statements. These are used for iteration. Then we have used the f-string for formatting and concatenating strings. Okay, now let's take a sneak peek into our code. So this is the dictionary in which we have entered all the food items along with their nutrients. This is the second dictionary for the exercises. Then these are the lists for meals and days. This is the EasyGui choice box that we have created here.
for statement and if statement. These are the F strings. And also we have taken all the data for the food items from the website called Fat Secret India. And for the exercises, we have taken all the data from the calculator.net.
So yes, since you have seen the code, you must be excited how the program works. So let's say. So we are selecting the day of the week, so we are selecting Sunday. And then what did you eat for dinner? Breakfast, porridge and aloo paratha. Let's say porridge, 20 grams, aloo paratha, 45 grams. Okay. Then what did you eat for lunch? Pav bhaji, utpam, jeera rice. Okay. Then pav bhaji, let's say we have it for 30 grams, utpam 40 grams, and jeera rice 50 grams. Okay. Then what did you have for your snacks? So samosa and momos. And then 30 grams of momos and 20 grams of samosa. What did you eat for dinner? This pav bhaji, jeera rice, tur dal. Okay. The pav bhaji 20 grams, jeera rice 50 grams, and tur dal 70 grams. Okay. Then what exercise did you do? Not walk. I'll dance. Yes. How long? For half an hour only, 0.5 hours. Then this is the whole report of the day. They are like, you can see total calories, total carbohydrate, total protein, total fats, and here are the like what we intake, calories in our food, carbohydrate, protein, and fat, and what we burn, what we use. This is other for nutrients needs during exercise, calories, carbohydrate, proteins, and fat, and this is the result where we have subtracted exercise 1 from the total nutrition value. Now we'll save this file in a folder, Nutrition Analyzer, where we have saved all other days, like Monday to Saturday, and we are saving Sunday as well, there only, to plot the graph. So yes, we are getting okay options, yeah, that your file is saved. Do you want to continue or exit? So here's the option continue or exit. Like this is our last day, so we'll continue it. Otherwise, if we are, when we were doing for Monday to Saturday, we were exiting it because we don't have to plot the graph then. Now we have to plot the graph. That's why we are doing continue. Okay. Okay. Then we have to select the folder. So nutrient analyzer as nutrition analyzer, as we have saved all the files there only. Yes, this is the whole graph for the week. Now here, x-axis represents days of the week and y-axis represents amount. Calories, excess calories are there in calories per gram, and carbohydrates are there in grams, proteins in grams, fats in grams. Now you can see how you consume your all these macronutrients and calories for the whole week. Then what are the future developments that we are thinking for this project? So yes, expanded database, like we have limited food items, limited exercise options. So we want to expand it so that user can have more choices. Then enhance user experience so that we can improve interface and accessibility for this nutrition tool. Then personalized recommendation means tailoring advice to individual needs. Then we're also planning to integrate it wearable devices like fitness trackers. We can say smartwatch is one of them. And then the last but the most important, we want to make it as an application so that everyone can install it on their Android and use it. Then what are the implications of the project? Yeah, there are, it has implications in various areas like healthcare and wellness, fitness, sports, corporate wellness, education and research, government and public health. These are all the implications. I hope you like this project. Thank you. If you have any questions.
Thank you for that very insightful presentation. Yes.
I really like the project. It is amazing. Everyone should use such applications. So I have two, not exactly questions, but kind of suggestions. One is that we are inputting mass of how much we eat. But that is not a convenient measure, right? Because I don't know how much pav bhaji I eat. I know how many pavs I eat or how many chapatis I eat. So I think portion sizes would be more appropriate. And the second thing is, what if we can, somehow use image recognition AI so that like we know when something has more oil or less oil by looking at the thin layer, right? So we can use image recognition AI to, know how much of something is there in a particular dish, so we can have more accurate meal tracking. That was just an idea. So have you guys considered it? And if you have, then what are your thoughts on it?
Yeah, we are planning for that. We are planning like future developments that enhance user experience, so we'll have improved interface. And yeah, we are planning to keep in it another amount instead of grams, because it is difficult for us to measure it in grams. So we'll do that. We'll modify it.
In this short time, we could make it this, so we have done like in grams. In future developments, we can work on that.
Your project sounds really interesting. I was wondering how you're accounting for differences in recipes. Like a cheese pizza I might order from Domino's would be far unhealthier than one that my mother would make.
Okay, so for that, we will expand database, and yeah, we are using also, we will use API keys where all the food items will always there, and we'll extract their nutrient values from there, so that it will be helpful.
So these types of solutions I've also noticed work in more areas where you buy a lot of food, but in India especially, a lot of us will just eat home-cooked food. And then, like he also pointed out, with recipes that changes, and you could use AI to identify some parts, but how do you account for all the nutritional values that change with the vegetables you get in your locality? There might be some source that's more organic, some source that uses more artificial ingredients, etc.
Like as I mentioned that there was API key and all that. So there we can get all the food items in different situations. Like when we have apple, so there are many options for apples. Which type of apple we want, like that.
Yeah, so I would like to say the presentation was very nice, and my question is that can we use this technology for wellness centers, health and wellness centers, and what are your future plans for it?
Yeah, when we'll modify it and we'll turn it into
was wonderful, the idea behind it and like the implications and how it can be used in day-to-day life is like amazing, and I commend you for that. So I have a sort of question/suggestion that it's related to like regional variations in food products and how they will also have different nutritional values. So is it possible that the database could be expanded to include regional variations? Let's say, for example, in Assam, a certain type of sabji will have different nutritional values due to the different type of soils rather than elsewhere in India. So is it possible that the database can be expanded to accommodate that? Because while there will be, even in any small region, there will be certain amount of variation, but an overall average can be taken of the designated locale, and that can be used to decide what the nutritional thing will be.
Yeah, we are somewhere planning it to convert it into an AI and machine learning application. So through that, we can detect what the food item is there. So according to that, we can get the information about that.
All right. Thank you, Shivangi. Thank you, Shishadri. A round of applause for them. And as we conclude the QBio and computational analysis section, we also would like to thank Professor Sudipta for their support and supervision. And now I will hand over the mic to Ambika as we close the first part of our presentations today.
Thank you very much, and it was really, really good. I think a big round of applause for all the students who actually presented, participated, And from last year, I think even the people who were present here last year, I think there's a huge jump in the way the presentations were being made and the questions being asked. So kudos to you guys. So I also would like to give a small token of appreciation to all our special guests here, Chintan, Prachi, and Shubham, for spending the half a day with us and more to go. So this is something that's a bookmark from us.
Thank you so much.
You take it home and that is done, and now we can break for lunch, but there is 2 exhibitions which are very important. One is AI and robotics, and another is branding and communications. So all your friends have their products, prototypes, everything ready for you. You can see the schedule where the 2 places are. One is called a white box, which is in AC04. That's where AI and robotics is present. The exhibition will start sharp at 2:30 p.m. and it ends at 5 p.m. And parallelly, you have the branding and communication next door. So just look at your schedule and go to that particular room and engage with them, ask them questions, and understand what they were trying to do. After that, we have a photo session, which is at 5 p.m. sharp. So it's very hot outside. This is going to be near the HDFC library, the stairs that you can see. You would have seen it last time also, where we were doing it. So please don't late because it's very sunny, so we don't want to be standing all out there. So please be on time, and after that you are free for the day. I think there's a sports tournament happening. And we also have one set of presentations exactly like this tomorrow morning starting 9:30 p.m. So please come in advance so that we can start on time. And after that, as you know, it's a graduation ceremony which happens tomorrow. So if there are any questions about logistics, you can ask right now. The students who have not sent the presentations for tomorrow, please send it into the link, okay, so that we can load it and make it ready, so that we don't lose any time there. All right, so thanks once again for all the encouragement and all the great presentations that you've guys done. Thank you.